So we have our first speaker, Dr. Angela Frazier. I'll let her introduce herself a little bit better, but she's going to go into some insights on produce safety for us. So take it away. You can use the clicker.
Oh, okay, great, thank you. Thank you very much. If you could, Laurel, if you could just give me when I have 5 minutes, I just want to make sure that I stay on track here. So before I go ahead and get started talking about U.S. insights and produce safety, I have a question for the audience. How many of you have heard of the Reagan-Udall Foundation Produce for Food Safety Roadmap? Raise your hand. So those of you who are raising your hand, keep your hands up. How many of you have actually read it? Okay, I know a number of you I see here in the room have been actively involved with that. And that was a very important undertaking. And there were over 150 stakeholders who were involved in identifying issues related to food safety. And there were two key themes that popped up for me that I think tie into why do we need to focus on insights. And that is, one, resources. We all need more resources to be able to investigate causes of foodborne disease. And secondly, and very importantly, collaboration. Collaboration across the supply chain, and what that means is listening to everybody at each point in the supply chain. So sorry about when I uploaded my slides, some of the fonts. I'm really picky about my slides, so this is going to drive me bonkers, but apologize for that. So why study insights? Okay. Well, the purpose of studying insights is we can identify factors associated with implementation of food safety practices. So we need to understand the context. And so I sat in on the sessions this morning, and the good thing is all the speakers began to address context. And we've got some really good talks coming up after mine today. The one thing that we have to remember is food safety practices don't occur in a vacuum. There are many reasons why people do what they do. And so I think sometimes when we share information about food safety, we forget that message. So context is important. And so when we look at insights, and insights cover a gamut, we could define insights in a number of ways, but it helps us to inform smarter, more effective solutions. So an example, we're collecting data on our farm, shows workers skip hand washing during peak harvest hours, where we start to get a little miffed. Why aren't they washing their hands? We know the relationship between hand washing and the transfer of pathogens. So we immediately blame the workers, or we say we need to provide more training. Well, when you start stepping back and looking at the situation, we realize that the hand washing stations are too far from the field, during busy times, and that's the reason why the workers are not doing it. So that results in a better solution. So again, understanding context is critical. So I'm going to start off by sharing some issues facing the U.S. produce industry, because this can also establish context. So I'm going to go through these 7 quickly and then kind of summarize what I see here. And there are many, many different interpretations. So labor, not enough workers. We start to skimp on how we're doing things. We don't do things because we don't have workers. Wages are rising, profitability. I think what people need to understand, and this came up during the Reagan-Udall deliberations, is particularly on the grower side, profit margins are thin. These are businesses, okay? And you have to remember people need to make money to be able to stay in business. And so I think sometimes our recommendations aren't always practical from an economic financial perspective. Price stability, big unpredictable price swings, this mostly affects growers. Climate resilience, Laura did a really nice talk about flooding, and there's other issues related to, climate problems. The supply chain, better logistics, but still fragile. Food waste, particularly from the growers, large losses from field to store. And then competition. I have heard this from a number of domestic growers. Some farms are stopping operations because they just cannot afford to grow because there's so much international competition. So when you look at all of these issues, I think the one that rises up is cost. And so again, when we're thinking about food safety practices and making recommendations, we need to think about, is this going to be an economic burden on the grower, the distributor, et cetera. That is critical. So we also know, fresh fruits and vegetables are the #1 source of foodborne disease in the United States. And approximately 10 million cases of foodborne disease each year are attributed to eating contaminated produce. This is a wonderful conference. There's a lot of conferences that focus on food safety, and particularly on produce safety. But we don't seem to be making a dent. And I have more radical thoughts about how to approach that. We've got a lot of good research being published. We have a lot of good studies in place. We have regulations. But why are we not making a difference? Again, we're not looking at context. That's my theory. And so I think we need to do a better job of that. And again, food safety is not a competitive advantage, but foundational to doing business. IFPA had administered a survey and asked how much money were members spending on food safety, and specifically food safety training, and it was shocking to me. For some large firms, it was about $8,000 a year. That's not a lot of money. And so I think also we need to do a better job, and I think sometimes we think, well, we'll take the risk. We know we want to provide safe food, but we may take the risk, or maybe because some of the practices that we have to implement are too costly, or we don't have enough labor, et cetera. Again, context. The International Food Information Council, I think it's almost every year, they administer a survey to assess food safety, the pulse of food safety in the United States. And if you look at this, you'll see the top row is where people have responded that they're very or somewhat confident in the safety of the U.S. food supply, and on the bottom, very confident. It's going down. You look at that. Now, as a scientist, you have to step back and you have to start thinking, why might this be? And I always think, could it be the instrument that was used to collect the data? Was there something happening at that time? But still, we see the downward trend in confidence about food safety. We have FSMA. We have regulations. We have a lot of training. So why is the public still not confident, or why is the percentage of people who are confident in the food safety supply decreasing? And here are their top food safety concerns. Foodborne pathogens. So a lot of times when we focus on produce safety in the United States, we think of microbial hazards. And when you go to Europe and Asia, microbial hazards are important, but not as important as chemical hazards. I spent 3 weeks in China, and they didn't really care about, I don't want to say, they weren't interested in talking about microbial pathogens. They were very concerned about heavy metals and pesticides entering their food supply. And so here, an IFIC polls a U.S. population. So people are concerned about foodborne pathogens, but also pesticides, cancer-causing chemicals, and heavy metals in food. And so I think in the U.S., within our research, our lines of exploration, we need to start focusing more on chemical hazards. And then what is the consumer trust in the safety of the food supply? I did a quick and dirty literature review just to kind of determine how do consumers in the United States feel about our food supply. And this is just a summary. And I think it all centers around, one of the keywords that I searched for was trust. And trust means different things for different people. Okay, so we have to define what do we mean by trust. And so if you look on the far right, commitment to keeping food safe. Are you competent in keeping food safe? Do you care? Is it predictable? So here are 4 key findings that I came up with when I did this literature review. Consumers show moderate trust across the supply chain. Production agriculture trusted the most. That's really important. So people do trust their growers, okay? There's others they don't trust across the supply chain, but, in this particular study, they showed that those who they surveyed, trusted production agriculture the most. Trust varies by country. Farmers, again, and retailers generally trusted more than manufacturers and authorities. Again, a good thing for growers. Farmers who demonstrate benevolence, integrity, and provide accurate information, raise or increase consumer trust and influence purchase choices. Again, they trust the grower. And then lastly, demographic differences matter. Lower income and less educated consumers rely more on family, friends, and farmers for reassurance. So you see a theme across here. Farmers/growers are really important and can be critical messengers to promoting food safety in the United States. This was a survey conducted by IFPA, and these are areas where those who were surveyed, we showed low confidence, and then here are some of the leading concerns. And so consumers were surveyed. Believe profit prioritized over safety, 59%, okay? Growers have very thin margins. And that came up in Reagan-Udall. The suppliers were, concerned about the buyers setting prices and not understanding all the constraints in growing product, et cetera. So, and the public is believing, profit is prioritized over safety. But again, if I was working with consumers and developing a consumer message, we have to understand these are businesses, and we have to help people to run a financially stable business. Perceive not all parts of the food system working together to ensure safety. Another one of the key themes that came out of the Reagan-Udall report, collaboration. We need to better collaborate across the chain, food supply. No one part of the food supply, academics, government, industry, nobody is better than the other. We all need each other, and we all need to be talking, and we all need to be collaborating. That is the way that we're going to decrease the number of cases of foodborne illness attributed to eating contaminated produce. And remember, 10 million cases a year, number one cause. Believe insufficient government regulation, and I think some of this may have to do with the government not explaining the purpose of regulations, and again, it boils down to messaging. And then 43% believe that there's too many food recalls. According to another survey, or according to the same food safety survey administered by International Food Information Council, IFIC, fewer people believe imported foods less safe than U.S. grown foods than in years past. So historically, the population thought that domestically grown product was safer than product grown internationally. And so that is not the case according to the most recent IFIC survey. So in 2014, 52% believe imported foods were less safe, whereas that's dropped down to 32% in 2025. And I know that this is a little bit of a contentious issue, but we do have a global food supply. And so even firms that are headquartered in the United States have growers that are located all over the world. And again, here's another bit from an IFPA survey. 73% of U.S. shoppers want more visibility on food origins and safety. And then again, trust in farmers relatively high, but expectation for transparency. So they want us to be more transparent about our food supply. So how, where, and under what conditions is produce grown. Because with transparency increases confidence in what you're purchasing, and if you have confidence, you're more likely to be loyal, and if you're more likely to be loyal, you're more likely to purchase. And again, that helps drive the business. Because if you have loyal consumers and they're more likely to buy your product, then you can stay in business. And if you go backwards, you need to make sure that they're confident with your product, and to do so, you need to be more transparent. Also, according to an IFPA consumer trend tracker, and the sample size for this was 750, is U.S. consumers generally associated better food safety with specific produce attributes. And so what are those produce attributes? Locally grown, organically grown, and field grown. I'm like, I was not involved with that survey. I'd go back and rework that survey because it's like, field grown? That's kind of a little bit on the goofy side, And so that's why sometimes when you look at survey results, I'm real nitpicky about that. I'm like, that doesn't make sense. I need to go back and look at that tool. But these were the findings from that survey. And they perceived all three of these as very safe or extremely safe. And then this is just kind of a breakdown of the consumer perceptions. And organically grown continues to be viewed as more safe than what I would call, conventionally grown. And I would imagine that when people saw the word field grown, I think that they were in their heads thinking of conventionally grown product. And I think this is a really interesting study that IFPA did, and I believe that they're in process of preparing this for publication. So this relates to recalls and demand, and the sample size for this was a good size sample of 500. 60% of the respondents avoid an entire food product category after a food recall. It can decimate an industry, okay? So somebody pointed out to me one day, and I thought this was really interesting. So let's say Skippy peanut butter is recalled, okay? People recognize Skippy peanut butter. It doesn't necessarily translate to all peanut butter because they understand there's a specific brand that was involved in the recall. The problem with fresh produce is the brand is the entire group. So when there is a recall or an outbreak associated with tomatoes, and I remember back in 2008, sometimes the dates get messed up in my head, people all over were not purchasing tomatoes, even though tomatoes from certain geographic regions were not even involved in the outbreak. And so that's one of the challenges within the fresh produce sector. The other thing is 47% stop purchasing product item for less than a month after a recall. So what that means is it used to be believed that people stopped purchasing a product for a much longer period. But here in the United States, I think we have very short memories. And you know what? What we're all riled up about one week, next week we've already forgotten about it. And according to this survey data, it's the same thing. And so I had encouraged my colleagues to please publish this because I think it might ease some of the minds of people who are working in the industry. So I've just shared, just some survey results, some different factors that affect the produce industry. So how will we go about addressing these? Because our intent is to decrease the number of cases of foodborne disease. And again, 10 million cases a year, the number one cause. So we hear about food safety culture a lot. And I think one of the challenges of food safety culture is it's a very nebulous concept, and I don't think we have come up with a good operational definition of how to implement and how to measure. And so in a nutshell, food safety culture is food safety begins at the top. So whomever is the decision maker for the business, the firm, they need to believe in the importance of practicing food safety. And they need to create an organizational culture where safety is prioritized at every level. And I know sometimes you can have a leader who supports something, but it doesn't always trickle down. And so when you approach food safety culture, it can't be using an authoritarian approach. So you have to use more of a carrot than a stick. And so I came up with some key food safety messages that I thought needed, to be shared across, an organization, so that everybody from the person who is the custodian all the way up to the C-suite understands. And food safety is a core business risk, not just a compliance issue. Protecting brand and reputation is protecting shareholder value or protecting your job. I visited a small plant in rural Ohio, and the thing I thought is, gosh, if they ever had an outbreak and that they went out of business, there's a lot of people here who would lose their jobs, and this is one of the only employers in town. And we've got to remember that. And then strong food safety culture drives efficiency and innovation, which can decrease cost. And again, it boils down to money. So we've invested a lot in training, and this is where I have spent the bulk of my career, is focusing on how to design and evaluate training initiatives. And so I think I have a much different approach to training. I believe we need to move beyond it being, we got to do this because the government requires this, or, our buyer requires it, to a commitment to doing the right thing, okay? I see a lot of trainings as we've checked off the box, okay? We've done it. And so we just assume that because we've done it, something magical is going to happen. And I've been in this business over 30 years, and you know what? There is no magic. Sorry to break the bubble. And so a couple of key themes when approaching training is, you remember, you're training humans, and they are critical to this whole process. So good quality training can result in building ownership and accountability, and then I'll explain in a bit how you can go about doing that. And it helps to integrate food safety into the organizational DNA, which is what food safety culture aims to do. And very importantly, creates a speak-up environment. Sometimes the best person to tell you what the problems are is the person who's working on the front line. What is that TV show, Undercover Boss? The CEO goes in there and they're like, wow, I did not realize that this was happening. But oftentimes the frontline worker is the one we don't go to for solutions. We don't value their input. And they're the ones out there in the field harvesting, they're the ones cleaning the equipment. And you know what? They might have the answers. And so value everybody within the organization. So a couple of years ago, I worked with two colleagues at the University of Florida, Drs. Amy Simone and Kim Wiley, and we conducted a systematic literature review of produce safety training. And we wanted to determine, across this body of published studies, what is the effect of training on produce safety practices? And we use PRISMA, which is a very rigorous approach to designing a protocol for conducting a literature review. And so within the field of public health, you look at quality of evidence as a triangle, and at the very top, systematic literature reviews and meta-analysis yield the best quality of evidence to support and inform training or practices, okay? And so we use that approach. And this particular paper, this particular study was published in Journal of Food Protection. So after our search and screening, we identified 21 published studies, which we further analyzed. And there is a lot missing in terms of good quality evaluation of training programs. Now, some people, when I come up and I talk about this study, and I've published 2 book chapters on we can't prove that food safety training works, they kind of get a little upset with me, and I'm like, no, that's not the intent. The intent is to inspire us to do a better job, to really think about it beyond checking off a box. And so of the 21 published studies included, 15 measured change in knowledge, attitudes, and skills. And so these are all self-reports. I know a lot. Do I act on it? And I remember when I was doing my orals for my PhD, I was asked a question, a nutrition-related question. And I said, you know what? I know what I'm supposed to eat, but I've been eating junk food every day because I am so stressed, and combo meals are cheaper and more convenient. Because my context at that time, I didn't have time or money, and I was so freaking stressed out. So the point I'm trying to make, people may have the knowledge, but they don't necessarily act on it. And then only one of those studies was designed to demonstrate true cause and effect. That is the only, you must have a control group, those who are not exposed to the training, and compare those to those who were exposed to the training if you're going to show a true effect. Now, having said that, it can be very difficult to do that, so we have to use caution when we're sharing results about training, okay? And so the message here is we need to do better evaluation so that we can better prove the effect of training, and so that we can identify potential gaps in how we're delivering training programs. And so at the same time I was working on that particular study, I was invited by the journal editors of the Journal of Food Protection to prepare a paper on food safety training. And so I was working with Dr. Kristen Gibson at University of Arkansas and her PhD student, Thomas Yergin. And we did it a little differently. I said, you know what, I'm not going to do the same old, same old. And so I wanted to try something different. And so our particular paper, we call it the 6 Steps to Knowledge Sharing, because essentially training is sharing knowledge that we hope people take up and use. And so if you look here, there are 2 dyads here. So dyad 1 is the creation or development of your training program, and dyad 2 is where you use it or delivery, okay? And you'll notice the educators, food safety educators, extension agents, extension specialists, folks who work in the industry are critical to both, okay? So if you look over at the left under dyad 1, create, it starts with generation. And what that means is generating good quality evidence and science to inform the practices. So a lot of the university faculty who are here in the room are doing that. They're generating the evidence so that that can be included in a training program and then ultimately shared with end users. Then the next thing is adaptation of those findings. And we have to remember, a lot of times the people who we're working with don't understand all the scientific terms, all of the acronyms, et cetera. So we have to adapt that concept, those concepts and findings, so that it is meaningful to those we're delivering that information to. Then we have to decide how are we going to disseminate. And in public health in general and in health sciences, dissemination and implementation science is a true discipline. I have yet to see it really actively taken on within food safety and in the agricultural sector. And so I think that that's something that really needs to take place. How do you disseminate? And one word of caution is we tend to put a lot of things online now. And I remember during COVID, when I was still teaching, students would ask to talk to me, and everybody was learning online, and they were crying that they did not like online learning. And so I think, again, we need to really reevaluate doing everything online. And I get it. I mean, I'm a very practical person, but that may not be the most effective approach. Or we need to think of a more effective way to deliver online. Then, now you get to the delivery, reception. Okay, so you've got all this content. And so during the delivery, during the delivery session, you want to make sure that people are receiving the information and willing to receive the information. I have, sat in on required online trainings, and I've turned it on and I've gone to the bathroom. Okay, I'm being honest, you know what I mean? Or you're just sitting there planning, what am I gonna make for dinner tonight? That happens, and I've asked colleagues, and they're like, yep, you're normal. We all have done that. And so, again, are people really receiving the information? Then you receive it. Are you going to adopt it? Are you going to make the decision, yeah, I'm willing to do this? Yeah, it makes sense. You know what? People hear it. No, I'm not doing that. And I'll smile. I'll pass the training. I passed the test. And then the last one here is really critical, the implementation, because knowledge about food safety does not decrease risk for foodborne disease or does not decrease the number of cases of foodborne disease. Implementation of food safety practices does. And a lot of times the reason people do not implement is because the environment is not conducive. So think back to my first slide when I was talking about why study insight. We blamed the workers for not washing their hands. But we failed to realize that the hand washing stations were not conveniently located. That is what negatively affected the uptake of the training and the willingness to wash one's hands. So all of these factors matter, and so I encourage any of you who are involved in developing or delivering food safety trainings to remember this. And so I didn't put this on a slide, but the final message is context matters. And you really need to understand what individuals are facing when you give them information. And do your best during training to be able to help them to better implement. And what that means is when you have training programs, it needs to be two ways. It can't be just lecture. There has to be a lot of discussion and input from everybody who is in your training audience. So thank you very much. Appreciate being invited. And I don't know if I had time for maybe one question. Mm-hmm. Yes. Sure. Mm-hmm.
Quite frequently, and its point is to increase information and make sure that FDA is being held accountable and there's good communication between FDA and everybody else. So my question to you in reference to that is, you brought up the reasons why people don't trust farmers or don't trust their food. And they were saying organic is better than conventional, and that's what you're attributing that in-field is versus organic or conventional. Is there anything that's gone into that to help consumers understand better what their food is, where it's coming from? Because there's the foundations out there who put out the Dirty Dozen every year. And we all know that the Dirty Dozen isn't any better or any worse than anything else because they're talking parts per billion, parts per trillion, but nobody's counteracting that. No, the Reagan-Udall Foundation isn't doing it. None of the universities are coming against it. There is nothing out there to counter that. There's no initiative in general from industry and the foundations, the institutes, the colleges, the universities to say that, hey, you're saying our food is so bad and only organic, and it's not. Food is 100% now social. It's not for sustenance. So how is that handling it? Because everything you said here, these farmers are doing. They're doing their damnedest to produce. Is there the outliers that screw up? Absolutely. But they're doing their damnedest to produce food that's going to be safe for everybody because they're feeding it to their families. So I love the research. It was great. But for me, the takeaway was you just told me things that I knew. And how am I supposed to apply this? Or how are you all, as the researchers and these groups and foundations, applying it to fix the problem on the other side? Because when we talk 10 million deaths a year or illnesses a year to foodborne pathogens, how much of that is produce and how much produce went out? Because the cucumber outbreak this past year, there was over 30 million cucumbers went out, and there was 30 people who got sick. What is that even?
Okay, that's a lot. And so thank you very much. Wendy, right? Yeah, so Reagan-Udall Foundation just commissioned this study. They don't have monies or a dog in the fight, other than they commissioned this study. And I believe everybody who was part of the Reagan-Udall initiative to prepare this roadmap had good intent in mind, okay? And so I think there is the roadmap to produce safety. I think the next challenge is how do we execute that? And it is not all up to the government. And so I think the beauty of the Reagan-Udall initiative is it included everybody, it included academia, industry, and government, okay? So I just want to make that clarification. The other thing you bring up, a really good point, is messaging. And I do not think we do a good enough job of preparing consumer-facing messaging to help the public understand what growers are doing. That is a real gap, because these are well-designed surveys. Some of them, I would argue, some of the tools I would change, but the thing is, the findings are the findings, and so we've got to figure out what we can do with those findings, and I think we need to do a better job of promoting what industry is doing to keep the food supply safe. And lastly, there's a lot of high-quality research that needs to be implemented, but also when we're conducting research studies and we come up with solutions, we need to make sure that those solutions are not economically burdensome, and that has been a little bit of a challenge. And the epidemiological data does not lie. 10 million cases of illness are attributed to fresh produce. So we still have a lot of work to do, and I agree with you. And part of the consumer messaging could be, we've had X number of cases, but look at how much we have actually sold. So again, that could be wrapped into a consumer-facing messaging campaign. So thank you for that. I think we're done. I don't want to cut into Faith's time, so thank you very much.
Thank you. All right. My next two speakers want to come on up.
Oh, yep, okay, so Faith and I decided that we had the same presentation title, part 1 and part 2, and it didn't make sense when we were trying to coordinate slides, doing it part 1 and part 2, so we're just gonna do it Sonny and Cher
Tag
style.
team.
Tag team style up here. So I'm Michelle Danlock, I'm a professor and extension specialist at the university.
And I'm Faith Kreitzer. I'm a professor at the University of Georgia, and it was really my pleasure to lead this team of people to help answer a really valid question that we had in the Southeast, because, if you've been in food safety, you've been in produce, you know that whenever we do have an event and an outbreak that occurs, a lot of times when we're trying to figure out the whodunit, right, you will see mention animal operations within the area. Fugitive dust, animal operations in the area. And there was a question for us, a lot of the data that was going on through longitudinal studies and things along those lines that the FDA was driving was not based in the Southeast. And we have a lot of animal operations we'll see here in a minute. So we felt like it was important to start to collect some data so we could actually inform people, we're trying to manage these risks and figure out what's going on and where should they plan at and where maybe would be better not to plan at if they have options. I'm, we're part of a really big team of people. Some of them are listed here. I do want to call attention to Hallie Greenbaum. She was the master's student who went out and collected this data. We have, researchers at the University of Georgia, Manpreet Singh, Harshit Thipareddy, Abhinav Mishra, a lot of other support staff. And then we also had a team of people at the Auburn University who, Camila Rodriguez's team, who helped us when you're going to see we're sampling in Alabama as well, because we're thinking poultry, right? Georgia and Alabama are kind of the big fish in the room, and we needed to be able to begin quantifying that. Michelle, I'll let you introduce your team.
Yeah, so as we tag team back and forth on this, when you have the aggressive orange and blue background, that'll be me presenting. When you have the less aggressive red background, or red outline background, that'll be Faith presenting. So yeah, Faith is gonna cover the poultry operations, and I'm gonna talk about the work we did on cattle operations across a couple states in the Southeast as well. Our team at the University of Florida was myself, my colleague who is in animal science, Jason Scheffler, and then our two students working on the project were Laurent, a master's student, and Christina, a PhD student. And so, yeah, back and forth, here we go.
So ultimately, this question came up because we've had a series of outbreaks that when we go back and look at those reports that are generated, and this is not by any means definitive, right? In these outbreaks, there were references to adjacent animal operations. So we start with a kind of a series of outbreaks associated with leafy greens. Arizona and California are the focus here from 2018 to 2020. And that is where I would say really we started to see more and more interest around this topic area. And that was followed up by a Salmonella Newport outbreak in 2020, where we had a significant number of cases across 48 states. And once more, we had adjacent animal operations mentioned and potential for transfer onto the crop driving as a potential root cause. We'll follow that up with another outbreak in 2020 with Salmonella again in peaches. And here we had not as many cases as the onion outbreak, but again, animal operations referenced. And then finally, we'll look at Salmonella typhimurium in cantaloupe in 2022, where once more we had animal operations referenced. Now, within these animal operations, sometimes it's cattle, but sometimes it is also poultry driven, right? So a lot of questions in Georgia, right? Significantly, many of our growers will grow both crops, fruit and vegetable crops, as well as they'll have poultry houses, broiler houses. So they want to know, how do they manage this? And even if you're not involved in both industries, you're definitely surrounded by it in some instances based upon where you're growing at. So a lot of this work, we're really trying to find how easily can some of these pathogens transfer and potentially make it onto crop. We are really focusing on two primary pathogens, Shiga toxigenic E. coli and Salmonella, but we also threw in what we call those fecal indicators, right? So the E. colis of the world that do not make people sick, but are strongly associated with fecal contamination. Just to set a little bit of dialogue around bioaerosols, bioaerosols are defined as particulate matter, microbial, plant, or animal origin. I'm sure we can all pass a little test now on that. But a lot of times you're going to hear this described as fugitive dust, which kind of cracks me up, or organic dust. And here you see a feedlot, right? And many times they're trying to manage this dust and transfer through these, here we have a traveling gun here mounted in the middle. That's going to be on and irrigating and essentially tamping down this dust within this feedlot as a management strategy, right? We also have a lot of indoor animal feeding operations. And again, sorry, our fonts also got a little bit messed up when we went into this format. Here we have swine, and we're not going to really focus on swine because that's not a big production practice we weren't in North Carolina, right, or anything along those lines. And poultry, though, right, where we have these indoor animal feeding operations, and clearly they're going to be different because you are containing these animals for production practice purposes within this indoor facility, and you have exhaust then that you're managing, right? And also, if we did need to apply control, we can all theorize it would be way easier to do it while it would still be expensive from these indoor animal operations because you do have more concentrated outputs. So generally within our indoor animal feeding operations, you do have these exhaust fans, and these are exhaust fans that are coming out of a poultry house that you can see here. They're exhausting to the outdoors. You can also see right here, we have one of our weather stations mounted here where we're monitoring that airflow. Again, it's primarily driven based upon when these fans are on and operating. And you can also have curtains within these facilities that based upon ventilation needs, you can also have them raised and lowered. So it's not all just coming out of these exhaust fans if it's a really hot day, potentially. The Center for Produce Safety claims that bioaerosol risk is a well understood but substantially undercharacterized. And I kind of find that a bit conflicting, right? Because I think what they're trying to say is that we understand that this is a potential, right? But we really don't know what the risk is, or for instance, how far away should you be, right, when we're trying to answer some of these questions. And I think what we're going to find is that it is very driven based upon location and the climateric data there, some of the weather patterns there, and ultimately, what data that we get from Arizona and California probably is not going to translate very well to the Southeast, where we have factors such as humidity and wind speed and wind gust speed that really are different between those areas. California Leaf Greens Marketing Agreements has set recommended setback distances from various size feeding operations to ensure produce safety. But even they will recognize that, yes, more data would be helpful to actually helping people mitigate this risk if it needs to be mitigated. And we have an expert in the room, but as far as California LGMA, again, we can see some of the metrics that they have put up for trying to, again, take a first shot at, as we've had outbreaks, there needs to be some sort of a response, right? So this has been essentially what they've done, and it's been an iterative process. I would say that they do divide based upon how large the operation is, and you can see that there's difference in distances, and as you go up in size, distance increases. And essentially, they would look at grazing lands where you have far lower density is a completely different ball of wax versus those animal operations that are really more confined with more head per acre. You know, I would say when looking at neighboring produce and livestock, we're always going to be neighbors, and we call this being good neighbors is what this grant was called, that the USDA Specialty Crop Marketing Agreement funded. And the USDA, our Economic Research Service, points to a national rise in produce grown in fields that are really adjacent to commercial livestock. In 2016, we have almost 13% of fruit and vegetable growers indicating that they grew produce in a field adjacent to commercial livestock. This is not from Georgia. This is from one of the pictures I took when I was at Washington State. But what we have here is the canal, and this was one of the primary canals that we utilize for tree fruit production. However, it was also a large dairy production. And what you can see here, it looks like a traveling gun, but that's actually waste from a manure lagoon, right? So they have their dry components, but this is the water component, and they're putting it out on one of their forage fields. And you could literally see the droplets going into this primary canal that's about 90 miles long, and this is at the front of the canal. So everybody downstream is going to be pulling from that water and from all those laterals. And I don't think you're really checking 90 miles upstream to see what's going on. And if you show up on a random day, you are probably not going to see this all the time, right? So I think this does drive some of the complexities, and these growers are really, water moves. So it's really tough sometimes if it is a carrier from some of these animal operations. Looking here in the southeast, this is a map of our CAFOs as they come in. We have poultry in red, swine in blue, which we don't have a ton of, beef cattle in green, and dairy in purple. So you can tell that there's something a little different about Alabama, Georgia compared to Florida, right? And that we do have a lot of poultry within production within these two states. Florida leans primarily dairy cattle with a little bit of beef cattle production, but ultimately it is really going to be a different scenario. So that's why we handled these different groups slightly differently. There is a lot of bioaerosols research, and this is pulled from kind of the poultry standpoint. But what I will say is, and I know this is really small, this is all for what's happening inside these broiler houses. It's not what's happening on the outside and how that may be transferring to the outdoors. So we do have evidence that poultry can, definitely be carrying and shedding organisms like salmonella. For poultry would be very specific. But we don't really have a lot of data beyond what may be happening transfer-wise within that house. And a lot of this, honestly, is not only for transfer to other, birds in that flock, but also when you put people in it, right? They're looking at human health exposure and things along those lines. So we really didn't have a whole lot of answers when it came to trying to look at this. Some of the work that had been done, I would say Elaine Berry's group is this last little publication I put here, and I would say it's still one of the first and probably some of the best that we have for actually looking at transfer. This work was done at Nebraska. It was done looking at leafy greens transferring. If you're scratching your head, it's like, yeah, we don't grow a whole lot of leafy greens in that area. But it was some of the first work where we actually could look at, well, how far are we able to recover this in leafy greens from these feedlot scenarios? So our research question was, are fecal indicators, because we knew just by history, it's tough to recover foodborne pathogens from air. And we wanted to kind of take a stab at modeling things, so we knew it would, if we didn't recover any pathogens, we need to have some outputs. So we looked at these fecal indicators. So that's going to be our E. coli and our coliforms. When you see those come up, that's what we're talking about there. And they're especially E. coli, they are tightly linked to fecal contamination. They're a big part of the GI tract, and this is not the type of E. coli like Shiga toxigenic E. coli that makes people sick. It's just a natural part of our microbiome, an animal microbiome. We were looking at Salmonella, we were looking at Shiga toxigenic E. coli. Now for poultry, we only look for Salmonella because Shiga toxigenic E. coli are not really associated with poultry. Within the cattle, we look for both pathogens because they are reservoirs for both. We're really trying to answer, are they emitted through the air from commercial animal operations, and at what quantities are they present? So we were really trying to quantify these things because one would think if they were numerous in nature, then we would have a kind of a decline as we went farther out. We also wanted to know how do bioaerosol concentrations change by distance and what other variables influence their spread. We broke this down into two objectives because whenever you get started in research, you're going to start in one direction, ultimately, and then as you learn, you'll change. So this is divided by years, and so we present as objective 1 and objective 2, but it's really a difference in our methodology. So within objective 1, we're really trying to come in there and see how these setback distances change over time, and we were doing that with active sampling. This is shown here, our overall methodology. So what we had, here I'll go ahead and go forward one. We had these gigantic poles shown right here where we had air samplers that pulled in a known quantity of air. They're called Anderson samplers. And then we also had weather stations mounted here. And we had them at different heights, and then we moved them along a transect, essentially from either the border of a field where cattle were, or right there at the milking parlor if it was a dairy operation, or at the exhaust fan from a broiler house. Anybody who knows broiler houses knows there's never just one house, so we would pick a house, it would typically be a center house, and that house always had birds in it, so that were some of our rules. We would come in with the air sampler, and this shows a little bit of our methodology. This is in meters, so we sampled directly at that point, and then 50, 100, 400, and 1,000 meters downstream. And we're trying to quantify these pathogens directly onto micromedia, right, so we could count them, and that media is specific for cultivating them, or we were looking at these indicator organisms. These are what our weather stations looked like. Again, we're trying to collect a lot of climacteric data to see if there's any correlations there, if we found anything interesting. So within this, these Anderson samplers are deployed for 10 minutes. I will say this is a big limitation of this sort of approach, and I will tell you why we did it all in the same instance. It is important to try and quantify the volume of air you're pulling through. At the same time, these microorganisms get easily stressed, and the more you leave these samplers on, the more likely you are to actually kill them. And I know that sounds crazy as we're going through this. So we actually looked at literature, and it's been well documented that if you go past 10 minutes, you are not going to recover. You're actually going to kill off things even if they are present. So that's why we only sampled for 10 minutes, and we sampled at 28.3 liters per minute. So we had about 283 liters altogether at the end of that 10 minutes. We then had them essentially impinge onto, not impinge, but directly impact plate onto these selective medias. These are for the Salmonella and S-Tech, should only cultivate those organisms. But as we'll learn, sometimes you get some oddballs coming in there. And then we had our coliforms and E. coli. We then incubated those so we could cultivate them. We enumerated because we're trying to count them. And then for anything that grew for Salmonella or S-Tech, we actually had to confirm it because you will get oddball things that look like them but aren't actually them. And then that was done through whole genome sequencing. And then we looked at statistical analysis to look at any correlations. So I'm going to go first into our poultry results, and then Michelle's going to follow up with what we saw on the cattle operations. So we see here our data, and this is going to be in log transform units. You know, us microbiologists always like to put things in our weirdo counts, but just know if there's a 1 there, that is think of that as a 1 with the number of zeros behind it. So 1's 10, 2's 100, 3 would be 1,000. So that's what these counts really look like. And we have to do this for statistical purposes is why we do it. And what we have down here on our x-axis is a setback distance, right? So this is how far out from that point source were we. And these are total coliforms in our orange bar, and it's E. coli in our red bar. And what we can see here is at the point source, we have a fairly decent amount in that exhaust coming out for these indicator organisms. And think of E. coli and total coliforms as that E. coli is a member of the total coliform group. But as you move away, it doesn't have to be made up of just E. coli. There are other organisms in there. But what we can see is coming directly out of that exhaust, it's primarily made up of E. coli because those bars are almost parallel with each other. But as you get away, and as soon as you drop down to 50 meters, you're significantly decreasing the population of those organisms within these. This is an average of data across 6 different poultry operations, and we sampled them 6 times throughout the season. Essentially, we got down to very low levels, and these are not pathogens, right? These are just fecal indicators that we're seeing, but they essentially plateau at about 100 meters and stay pretty consistent. And it's also, we can't say that this is all coming from that poultry operation once we get, because there's other sources of these organisms within the environment. So there was no salmonella detected in any samples within it. So that's what I'll start with. I think that's the thing that makes everybody most, happiest. That we actually weren't able to recover it. We'll get into some other things we did to actually see if it was present or not. The greatest concentration is, of course, at that exhaust fan. And then at that exhaust fan, most of those coliforms actually are E. coli. For our meteorological parameters, essentially, I know that we think in miles per hour and not in meters per second. We have some of our data here. Ultimately, we captured this because when other researchers come in and try and compare data, it's important to know differences in regions, right, and what was specific to these sites. So I'm going to just put this up here, not that it means a whole lot, but for us being in the Southeast, we are a little different in that we're going to have higher relative humidity, right? We're going to have different ranges. And I think that's important for us to capture when we're out here looking at this sort of data because it is one of the things that makes us different. We also looked at particulate matter because that is one of the things that has been kind of identified, and especially in some other areas and through the other longitudinal studies. When we look at transfer, a lot of the models that say even the EPA builds for transfer of things in plumes is based upon particulate matter frequency and particulate matter size within that frequency. So we went in and collected that data at the same time we were doing this pathogen and indicator work. What we have here is our different sizes. So these are in microns, so it's 0.3 all the way down to 10. So if you've ever heard of somebody reference a PM10, that is essentially the particulate matter at that largest size that they're looking at. And we can see here that, again, we have our setback distances here, and we see, especially for that largest particulate matter, it decreases significantly once we get past that point source for our data set. Similar trends as we go up, and you'll notice the thing with the smaller particles, they do hang in the air longer. But in reality, what we're seeing is the best correlations from other sites and from other industries with actual microbes tends to align with PM10 data. I'm sorry. This is my graduate student's defense presentation. She would tell me I'm failing. So within that, some of the things that are helpful to break down is that if something's hitching a ride on a dust particle, essentially it's going to be in that larger category. If it's a free-floating bacterium, it's probably going to be in that smaller category, like a PM1 size. What we know is that most of these organisms are hitching a ride on something when we isolate them, and so that's why I say that PM10 is a little bit more. And then what we know is that the most significant decrease in particle size did occur for those larger particles as we were essentially at 50 meters. So not very far downstream. We also looked at concentration for these guys, and what we saw is that fine PM1 remains suspended in the air over longer distances. The other data was frequency, so this is the actual counts. Again, those intermediate PM2, which is our yellow bars here, and our coarse PM10 data, it significantly decreases at 15 meters, then plateaus, so very similar. When we looked at some of our correlations within this data, we had some moderate correlations, nothing to get like super excited about for all the boxes shown here between total coliforms, and here's our temperature and relative humidity and other variables, wind speed. So at some point, they were all correlated with either total coliforms. I would say the things that I would hang my hat on a little bit more as far as potential fecal food safety risk would be in that E. coli category. And we had some moderate correlations with wind speed, gust speed, as well as that PM 2.5 data. When we looked at really strong correlations for E. coli, what we saw was that PM10 data. And that's a 0.7% correlation coefficient. So that's a pretty good correlation coefficient in the world of anything above. That's like 70% of this is influenced by this factor. So that particle size does seem to hang in and give us a little bit more. Total coliforms, again, we're seeing a pretty good correlation with wind speed, but those are a little bit more broad categories, and they are found all in the environment, right? So they're not necessarily going to be just fecal association. You're next.
Okay. So I'm up next to talk a little bit about our cattle data. I will say this. We also, we didn't say this, we did sample while we were in fruit and vegetable production.
Oh, yeah.
And maybe that's a little bit different in Georgia and Alabama than it is in Florida when ours is all year, but we sampled all winter in Florida. They sampled in the spring and summer in Georgia and Alabama. So Faith's year one actually followed our year one, and that's gonna impact some of the data. So for example, we don't have particle size data because after our initial sampling and looking at those results, then we were like, oh, we should really add this. Let's start building those sensors. So we don't have that as well, but exactly the same setup as Faith, with the exception of we did not have those targeted exhaust fans to be our point source of contamination. We were at the milking parlor, or we were at the fence line of our CAFO operations. If you look at our meteorological parameters, very similar. Got our temperature range from 42 to 102 Fahrenheit, relative humidity 21 to 86. Wind speed was 0 to 79, or sorry, those two are wrong. It should be gust speed was up to 79 miles an hour, and our wind speed was up to 36 miles an hour. So pretty typical of what we would see across the states we were sampling in. So unlike Faith's data that she presented to you, all in graphs, we did not average between our different locations. We did average between all the different times we went to visit, and this is just the 6 visits we did in year one. We did not average between the locations because while you can call a poultry house with a fan, we didn't feel like it was fair to take these unique type of operations and average all that data together. Instead of presenting the data like Faith did to you in graphs, this is our coliform data. We have it presented to you in sort of heat maps. So where we have higher red data, that is where our coliform data was quicker or was higher. Again, we've got those 3 locations, and these are actually the heights of our sampling and the distances of our sampling. So this is 0.5 meter in height, 2 meters in height, and 5 meters in height, those different heights along the pole, and then at the different locations. What you'll see is 2 of our locations, we found our highest counts at that 0 point, so at our closest point to our source of contamination for coliforms. At this 3rd location, our highest counts very much happened at our furthest distance, kind of indicating that something else might be the source of that contamination. Again, that's across multiple sampling times. We really had something else feeding in out at that is at 400 meters. I think Faith's diagrams all showed 1,000 meters. We had to call this greater than 650 meters because we could not always get out 1,000 meters without hitting really significant tree lines where it didn't feel like it made sense for us to be sampling in the woods. And even at this one location where we did have something else going on, we could not get beyond about 400 meters to find anything. But again, a little bit different than what Faith saw. In 2 locations, highest at the first point, this last one really lower. The highest populations were out at the furthest point away. And kind of, again, at the lowest point, that 0.5 meters, so is that about 2 feet off the ground? Not quite. That is where we found the most, except in this location 2, where that 5 meters, that highest point, was where we saw the most. So that's our coliform data. Let's look at that next to our E. coli data. I will tell you, we found significantly less E. coli than they found at those poultry houses in Georgia. And again, you can see our by location differences. This is our generic E. coli colonies. Location 1 at that 0 meter distance had similar data to what they saw in poultry, and that was our highest. But then you can look at our other 2 locations, even at our sort of point of sample where we didn't have that exhaust fan blowing out, we struggled to pull anything. There's a lot of zeros here where we just didn't find anything. Faith said we did sample for STEC as well. These are our presumptive STEC, and I'll highlight that because later on I'm going to tell you none of these confirmed out as STEC. We didn't find any STEC in this entire study, but our presumptive STEC matched quite closely to our E. coli data, but were significantly lower. And then salmonella, again, this is presumptive salmonella data, was really all over the map. So you can see we had a lot more of higher prevalence of that presumptive data out there. Again, at location 3, everything was a little bit different, and that's where we saw it at that 50 meter mark. None of these salmonella confirmed to be salmonella in the end, and that is what's on this. We did whole genome sequencing on all of those presumptive samples there, and you can look at that location 1, salmonella, no positives, STEC, no positives, location 2, no STEC, no salmonella, location 3, no STEC, no salmonella. So across the board, we did not find salmonella. Much more positive, percent positive. Even our generic E. coli, we were only in that less than 15% positive, while we thought was presumptive. Generic E. coli actually turned out to be generic E. coli. So we were pulling a bunch of other things out of the environment. What were some of those things? And this in particular is what was showing up, what was showing up kind of across the board. But you can see Pseudomonas and Pantoia, some Erwinia, they were pulling out and showing up as presumptive pathogens in these cases. These are not foodborne pathogens, and they are not things that we would worry about, but could be giving false positives if anyone else was to go out and do this testing. So in summary, for our sort of year 1, objective 1 sampling on this, we didn't find any STEC or any salmonella in any of these samples. Oh, this is your slide. I should be.
It's okay, you can read it.
All of a sudden I realized it was red. All right. I also didn't show you any statistical data correlated to any of those weather factors. That's because while Faith had some weak correlations and some strong correlations, we had no correlations across the board. So our data did not correlate into any other factor. I feel like I need to let you do this.
It's all good. I want to throw Michelle out there and see if she wanted to present the data. So for what we saw at the poultry fan, again, it's the concentration of birds within these houses, I think, is why we're seeing so many more fecal indicators at that point source, and why we were able to get a little bit higher population, a little bit better correlations from there versus those open animal operations where even though that's where the most of activity is happening, it's not nearly as like directionally concentrated if you're pulling air samples. Essentially, we've got within the range of what we would typically see if we were sampling in other poultry operations. We did a little pre-work for this to try and work out, should we be using the Anderson sample or should we be using another type of sampler that's available? And essentially, within this data set, we had very similar results. Again, those indicators significantly decreased at 50 and 100 meters, so we didn't have to get very far downstream, right, to start to see these organisms drop out of the air for these indicators. That intermediate and coarse PM, so that 2.5 and 10, exhibited the fastest declines in frequency and concentration at 50 meters. And there's a strong to moderate positive correlation between total coliforms and wind speed and between E. coli in that PM10 data that we talked about when we were going through it. And that is supported by some of the other studies. And again, I would say it's really hard to compare some of these studies because they are apples and oranges, right? They're not in your region. They're not same climacteric information. And what we know from other organisms, and I'll give a preface to say that typically those other organisms are like animal pathogens, right, that will make animals sick. Foot and mouth, things along those lines, they can spread a really long way. So there is a lot known about microorganisms, while not these in specifically. And so what we know is that essentially humidity, what particle size they're going on, that sort of information does really drive how far they can travel, as well as things like directional wind gusts and things along those lines. So now I'm going to move into objective 2. Since we got a whole lot of nothing, honestly, from that first, we wanted to align more so with some methodology that was taking place in these longitudinal studies, where they were not doing active sampling. They were not only sampling for 10 minutes. They were sending cheesecloths out so that we could sample for longer periods of time. So we aligned with the team from Arizona, replicated their passive sampling methodology so we could begin to say, okay, if we leave these samplers out, and again, this is pretty crude, right? This is just cheesecloth that we're suspending on stakes from the ground at a set height. At these setback distances, though, still with our weather data, could we potentially recover some of these organisms? A little bit of the difference between the way that we did this, I did not do what we call enriching for pathogens, meaning I did not leave them in a media and just see, were they there at all? Because I was still in the mindset of trying to quantify. Michelle's team, when she presents her data, they did do enrichments to see like presence absence sort of data. So that's a bit of difference between this data sets between our two teams. So here's what we did. We had our same setback distances from these point sources, and then essentially we had enough weather stations that we could deploy them at the first 3 stops. We could not do it at the last 2, unfortunately. And we were using the same exact setup when it came to that. So we had those cheesecloths deployed for overnight. We did overnight. Why overnight? Night, not during the day. UV light's a thing, right? So we were saying, okay, we're going to do worst case scenario, right? Because the crop's out there no matter what. We're going to try and deploy these at night. We should have less desiccation. And if UV light isn't activating them, which they has a potential to, we should not have that interference. We set those cheesecloths out. We went and collected them after that 12-hour period, and then we put them into Whirlpack bags, and then essentially tried to elute these organisms off of those cheesecloths by stomaching them, and then we plated that onto this different media, and we incubated that and enumerated those plates. We also did the media for the specific for Salmonella. However, we never recovered anything, so through direct enumeration. So our results, looking at these indicator organisms, you're going to notice these populations significantly increase from what you noticed from the active sampling. That's because we left these cheesecloths out for 12 hours, right? So we weren't just sampling for a 10-minute time period. But in essence, what we saw, here's our limit of detection down here. So that's just the lowest we could ever quantify, but we were always typically above that. And what we saw, we had our greatest concentration of indicators at 0 meters, and then essentially we declined significantly. What I'll say is our coliforms were pretty steady after we got to 50 onwards. They really didn't change that much, but those coliforms, again, are regularly found in the environment. The thing that's more tightly found with fecal contamination are those E. coli, that red bar. So we can see they're still dropping off, and they continue to drop off, and where we see the most decline is in that 400-meter space there for these E. coli. We also looked at meteorological parameters, so we didn't ignore that data, but we were just collecting over a far greater time period. So what we see here is essentially one example across 3 different sampling visits, but we collected this data for every single operation we went to. Where we're collecting here, we have temperature in black and our relative humidity in red, and we can see we had very consistent periods throughout this 12-hour where it was pretty standard and fairly consistent across the board. We saw our temperatures ranging from, this is in degrees Celsius, 17 to 29, so about room temp, 70 or so. Relative humidity was 56.9 to 99.3, so high relative humidity, because, right, we have rain events and things along those lines. You have dew in the morning. You have all these things that drive this. We didn't see any significant correlations between temp and relative humidity with our indicator organisms. And essentially, this is known. This is just weather. Temp and relative humidity were inverse relationships. What we saw when we looked at some of our other meteorological parameters like wind speed and gusts, there were no significant correlations between wind parameters with any indicators and high variability. People tell you sample downstream from the wind. And then what you realize, and we probably all know this anyways, the wind's constantly changing. And in some areas, there is a prevailing wind, but in the southeast, many times, it can be changing pretty significantly, and it's not really blowing that hard most of the time, right? So it's hard to set out your transects, right? Because it could really change so significantly. While we know where it starts at for the poultry operations, it changes pretty regularly, and that's what we picked up from this data set. So this is the sampling heading direction, essentially that sometimes we had to adjust because things happen, right? Operations change, they start putting things into production. They don't want you in the middle of their field that they've planted in, right, when it was available earlier when you're in there sampling. So we did sometimes have to change and capture that information. For particulate matter here, it's the same sort of data. We captured this again over longer periods of time. So we really went in that whole 12-hour period, but essentially at 0 meters, it was associated with the greatest frequency across all of our PM sizes. Larger particles exhibit the most significant decrease as we step away, and it's very similar to what we saw when we were only sampling for 10 minutes, that we see a significant decline at that 50-meter location. The longer data collection resulted in more variability in our PM distance relationship, and that is to be expected, right? Because there is naturally more variability the longer you sample. As far as our concentrations, again, they were all greatest at that 0, and then essentially at that PM10, that coarse PM, we saw very similar trends here when we looked at that concentration versus frequency. So very similar across the board, passive-active. When we looked at our Pearson correlation coefficients, the only thing we saw that was even moderately exciting when we went at these longer periods, because we had more variability, was for E. coli, and only for 50 meters. I wouldn't really hang my hat on this. We had, kind of weak, moderate correlations for everything else, but it wasn't as tight as when we were doing the active sampling, which is to be expected given the amount of variability we have. Take it away, Michelle.
Yep, so when we move into the cattle, again, I'm actually not going to show you our year 2 data here because it was similar to year 1, low levels of E. coli and coliforms, no salmonella or SDEC detected. In our year 2, we did both active and passive sampling before we completely gave up on active sampling when we did year 2 in Georgia. We did both of them together. We found nothing, no correlations, again, similar to our year 1. We actually only had those particle size readers with us for one sampling event. They were very problematic to get going and get active appropriately, so we used them only for one event. I'm not showing you that data either. But the fact that we still, after all this, had no E. coli or no STEC and no salmonella kind of made me question everything about the experiment that we were doing, and this gets into where Faye started talking weeded enrichment, because I started wondering, well, what if there's just no salmonella or STEC in those cattle populations we're sampling, right? Don't expect that, but we've got 2 years now of negative data. My student really wants to graduate, and we've found nothing. Was it even there to start with, right? When I started to think of was it even there to start with. So then from one of the operations we were working with, we got permission to go into that operation and pull environmental swabs in the barn, enrich those for the pathogens, and then do the active and passive sampling, enumerate, but also do enrichment of those to try to see, do we even have it in this environment that we're trying to use as our point source to get it from? Because I had some paranoia that perhaps we'd put 2 years of work in to sampling something that wasn't there in the first place. Maybe we should have done this in the beginning, I don't know. But we did it at the end. And not only that, because we were so convinced that maybe it wasn't even there to start with. When you look at sampling methods for food, we typically do an overnight enrichment, right? And maybe overnight enrichment. Some of the rapid methods might be an 8-hour enrichment, but we might go up to 24. When you look at some of the poultry barn methods, in particular for organisms like Salmonella, they'll do things called delayed secondary enrichments, where they will leave samples for 5-7 days in these enrichment media, again, trying to tease microorganisms out of them. So we attempted those things again. So this is looking at just that one location where they let us go in and sample in those locations long time. In this case, this top graph is where Faith talked about putting those passive samplers, those cheesecloths out for 12 hours. We actually put them out for both 24 and 12 hours. So the blue bars are those 12 hours, the orange bars are those 24 hours. And what you can see is that solar radiation played a huge difference in knocking down those bacterial counts. That's not surprising to anyone, right? We talk all the time about how solar radiation and more time exposed to the environment lowers the population of these fecal indicators. We could see that very, very obviously here when we compared that 24-hour and 12-hour cheesecloth exposure, and that's why they were able to only do that 12-hour overnight out in Georgia sampling. Also here at the bottom this is our active air samplers, and this is coliform and generic E. coli, number of plates below the limit of detection. And essentially what you can see is that the majority, again, in those active air samplers was below the limit of detection, even when we changed the amount of time. So 5 minutes, 10 minutes, or 20 minutes. Again, trying to lengthen it to see if we could pull more out. We just very, very rarely had anything popping up in those active air samplers. This is our pathogen sampling data. So this is all combined active air sampling times, 12-hour cheesecloth, 24-hour cheesecloth. This is looking at the invasion A gene for Salmonella, and this is looking at STX1 and STX2, which are Shiga toxin genes in a E. coli 157 or an STEC. What we can see is that active sampling, again, nothing pathogen-wise. 24-hour cheesecloth, where it was out all night and then all day following, nothing on those cheesecloths. 12-hour cheesecloths, so just overnight cheesecloths. We were able, 4 of 6 of those, we did pull Salmonella off. In this case, I have combined all the different methods we used to get that data from the 6 samples we pulled. And then of the 30 environmental swabs that we pulled, again, combining all the different methods, 4 different types of enrichments, 27 of them were positive for Salmonella. So there was Salmonella in these, in at least this one operation that we were at. We just were not seeing it in our active sampling in the air, but could find it overnight. I should also say this is all at our 0.0, right? This is at the closest proximity to the operation. So there was Salmonella in the environment. It could have been spreading in the air, but our active sampling methods didn't let us find it. If we had our cheesecloth up during the day, we could not find it, but if we only had that 12-hour cheesecloth at night, we were able to find it. And again, even with enrichments, long enrichments, we were not ever able to pull that STEC out of the environment. So, we saw similar trends within cattle, which was no trend. We saw similar trends within poultry across the different states where there were some pretty significant trends. But again, nothing here that we would hang our hat on, nothing similar to what we're seeing out in some of the locations in the longitudinal studies on the West Coast, even with that longer air sampling time. Anything else you want to say in conclusion?
Yeah, sure. I would say that, you learn as you grow. I would say that we would need special agreements in place if we were to get into poultry operations. Everybody who's worked in broiler houses knows there's a lot of biosecurity in place, especially we were doing this in the middle of avian influenza, right? The last thing these farms actually wanted was us on their farm as outside people. And to get inside that house, we could probably do it at the very end. What we did do, though, and what we know about salmonella prevalence in poultry is that we should have had it present, and we hedged our bets, and we did it. Typically, broilers are grown out for about 6 weeks. We sample from 3 weeks onward only within those flocks because that's the time when you're most likely to actually isolate salmonella from them. I would say that it was a huge lift to do this work. This work, I've done a lot of field work, and this work was harder than any work I've ever done. I don't know if Michelle would agree with that or not. I give full kudos to the teams of people who came together to make this happen. We also really appreciate the funding source, and of course, all the operators who let us come into their operations and sample this work. So I think we have a few minutes for questions, right, Laurel? Maybe 5 or so. So if y'all have any questions, we really appreciate your time. I think at the end of the day, we'll see, but I would really like to give growers some hard and strong and maybe some ability to push back based upon where they can plant, where they can't plant, based upon what animal operations are around them.
Do you have any questions? Thank you. Ask a question.
I think so.
Lucy, do you have any questions?
What are you gonna do next?
Not this.
I think we're going to stick with passive sampling. We will lean into enriching, and we will probably lean into both kind of time periods, because that is the story, right? That there may be some opportunistic things that happen overnight, but even then, there's distance involved, and we see differences as we go out in distance. I think that data is going to be the strongest as we move forward. And, in an ideal world, we are developing models from this data based upon the fecal indicators. Those models we can then try out based upon our enrichments from our Salmonella and STEC data moving forward. And if anybody in the room wants to fund us, let us know.
Yeah, I mean, I think we really were pushed hard by our modeling team not to do that presence-absence enrichment data, not to do that overnight sampling, right? They want to define sampling times because those things are easier to model and they make recommendations a lot easier. We've got multiple years of sampling where we just were not able to get there. Get meaningful data in terms of pathogens with that. So I think if we want to find the pathogens, we need to lean into the passive sampling and lean into enrichments, and not even just the overnight enrichment, but some of those longer enrichments to really give those organisms time to survive. And yeah, at this point, we don't have additional funding to continue this work. So this will all be written up. We'll make recommendations. We do want to give folks the ability to push back with the data we've got, but we've just scratched the surface because, right, it's always harder to prove the negative than it is to prove the positive. And at this point, we're up against proving the belief coming out of the West Coast.
So yeah, I have a question. That's sort of, okay, so maybe, I don't know where you're going with your question, but you kind of led into my question a little bit. You mentioned in the beginning some of the rationale for this work was the 4 or 5 different outbreak events that had this listed as a contributing factor. It seems like from your data, it's quite compelling that this is pretty difficult to find. It might be rare. It's a little bit of a lightning strike event. Do you think that this really needs to, do you think this is one of those main contributing factors that you think is worth spending tons more money to investigate? Or do you feel like maybe there are other things that we're missing? It might look bad, or the perception is that this adjacent land use might be a contributing factor and a spread of contributing to these outbreaks, but even if you got it to find something, it seemed like it was a lot of work. And in terms of, I just don't know if that's what was contributing to these multi-state outbreaks to where then people got sick. Does that make sense in terms of?
Yeah, no, your question I think
Okay.
totally makes sense.
Perfect. Thanks,
Is
guys.
is the ROI here to continue doing
Thank
this,
you. That was
right?
such a shorter way to do it.
I don't know, that's, yeah. I mean, so for me, you can ask that question in two different ways. Is the ROI there in terms of public health, and is this where I would invest my money? No. Is the ROI there, and is there reason to invest money so that growers are not faced with mounting requirements from buyers related to setback distances, based on data that's unrealistic for the conditions that we're growing in the Southeast? Yes. I guess that's my answer. I don't know if you want to answer differently.
Yeah, I think if it helps a grower make an educated decision, then yeah. I mean, I want to be able to tell, because that's the thing. It's like, well, you have a poultry, broiler house. Well, how far away do I need to be? And what would you tell them? Right? So that's where all this started. I'm in the practical side of helping people with solutions.
And if somebody does come in and say, you need a mile from that poultry house, based on what's gone on the West Coast on a large CAFO with cattle, we want them to be able to push back and say, you know what, a mile's not really realistic. I mean, originally we talked about doing work to looking at mitigations, right? Like, what's the impact of a tree line? We think they're significant. That work we still have not looked at. And maybe we don't have to, based on the data we have right now.
No, it sounds like it's important to publish it, so, thanks, ladies.
I just want to say what an awesome job you did first. I just want to do that. I did want to ask a question about that third site, Michelle. You
Yeah.
did that weird site. Do you have any ideas why that happened?
Oh,
In the environmental sampling, you found 0 STEX or pathogenic E. coli in the cattle operation, correct?
Lower STEC prevalence in the Southeast is not uncommon when you compare them to your stressed out Western cows compared to our happy Southern cows. No, I don't. I'm not a cow. Jason could answer that better than me. The map densities of those cattle operations are not super high, so I have to be really cautious with what I say about them. I have to be really cautious about what I say to not give a location away. What I will say is Faith showed a fantastic picture early on about a dairy lagoon spray out field. Perhaps we didn't consider that high enough in our sampling.
Yeah, I just wanted to say as well, really nice work. We've done similar work in North Carolina. We published it 15 years ago. We actually followed up with the modeling part of that as well, so that we modeled how far downwind that this could be an impact. And we found very similar work. We worked both in broilers as well as with layer houses, and never found salmonella in air samples. We did find indicators, and that's what we based the modeling data on. But if you go back and look at the longitudinal study that FDA did, which I'm sure this is trying to address, those were very, very specific environmental conditions. So, I agree with y'all wholeheartedly. I think East Coast, West Coast look very, very different, and you have to take it on a case-by-case basis. Very good job.
Thanks, Chip.
First slide, yeah. Our next speaker is Scott Monroe from Purdue University. He's been doing a lot of survey work with cantaloupe, and so I will let you take it away.
Okay, well, greetings from Indiana. I guess the first question that most people have is, why are we bringing someone down here to the Southeast from Indiana? Well, because we grow a few cantaloupe in Indiana. We have poultry operations in Indiana. And we face some of the same issues, and in the summertime, we have a similar climate. Second week of December, we had 6 inches of snow on, but in the summertime, we have a similar climate. So I just want to take a little time to talk about some of the things that we're doing at Purdue, some of the things that are going on with regard to food safety research. We have an exceptional team at Purdue University dealing with food safety, especially with the produce. I work as a food safety educator. I'm stationed in Vincennes in the southwest part of the state in our melon-producing regions. Dr. Amanda Deering is on campus, kind of anchors the team. Terry Gary is also on campus as the administrator and the one that keeps us all moving in the right direction. And Catherine Paraga is our new outreach specialist that came on about 1.5 years ago. So between all these folks, we form what we call Safe Produce Indiana, which is kind of the name we go under. And we also, if you want to check us out, here is our website, safeproducein.com. Unless you're in the southern part of Indiana, then it's safeproducin.com. So just very quickly, one thing that I do want to highlight that they mentioned what's going on in cantaloupe. Nationally, not a lot, but I will mention that they're in the process, folks are in the process of updating the national guidance, food safety, or commodity-specific food safety guidelines for cantaloupes and netted melons. So what we're anticipating, this has been a long process, and the first part of that is probably going to be out within the next month or so. I communicated with Western growers this week, and we're looking at possibly a workshop in April in Dallas or Denver, a national workshop to kind of go over these new updated, revised guidelines that haven't been updated in some time. And I know a lot of us in the room are involved in that process. So, things we are doing at Purdue, some of our research activities, things we're working on. One project that we've been involved with that was funded by a specialty crop block grant is our food contact surfaces project. We don't do fancy up in Indiana, so this is about as practical as we know how to get. This was a 3-year project looking at the suitability of materials for use as a food contact surface in transport vehicles. So in our area, melons are transported in wagons or buses. So, the question becomes, what do we do? We can't really line these with straw. Where do you find food-grade paint? And good grief, is it expensive? So the question was, what might work in place of these materials? So what we did, and we had some excellent farms that cooperated, made this possible. We took some different materials that we might find being used to line or cover buses or wagons. Bare wood, spray on rhino lining, spray on rubber, some vinyl, metal, epoxied wood, and then we just used as a control the surface of the wagon or the bus itself. And you can see in the picture how we did that. These units, we just basically embedded these materials in an epoxy, and we just put them in the wagon and let them ride for the season to see what happened. Again, we like to keep things simple. Once these units were installed, we swabbed them weekly, took them back to the lab, and then basically stomached them, plated them out on some selective media just to see what we had. There were differences noted between the materials. Now, were those differences strong enough that I can make a recommendation? As is often the case, no. I really wish they were. What we did note is that the epoxied wood seemed to show a little bit of promise for use in these wagons or to line wagons or buses. And again, this is something that, once we get some funding, we really want to flesh out a little further. We were using just a regular woodworking epoxy, like a woodworker would use to fill cracks or and do projects. one thing we noted is that when the temperature of the material got a little bit warm, like greater than 130 Fahrenheit, it started getting soft. And in some of those wagons in the open sun in the middle of summer, yes, they're going to get hot. So our question is, are we seeing what we think are differences because these materials lend themselves to more efficient cleaning and sanitization, or are we seeing this because they're getting soft and the bacteria are getting stuck and embedded on the surface? So again, we're wanting to do a little more work, see if we can repeat this down the road with some higher temperature resistant epoxies, and see what we can do. So that was a project that we did down at our Vincennes facility. Again, our team is split just a little bit. Purdue's main campus is in the northwest part of the state. Our Mellon and produce region is in the southwest part of the state. So, which is really nice because we've got two facilities we can utilize to do some of this work. The other thing we've been working on, and this is something that Dr. Deering's been working on up in her lab on main campus, looking at the effect of netting density on the efficacy of post-harvest sanitizers. So, someone help me out here. Cantaloupe in some places seems to have a bad reputation. Justified or not. Does anyone tell me what the most identified problem is with cantaloupe? What makes it such a high risk? Anyone have any ideas? I heard it, yep, netting. You've got a rough surface. It looks like a little bit of a rough surface. You get under a microscope, it looks like a cave system. It's really interesting. But, you get bacteria embedded in that, and it just becomes very, very hard to get out. So the idea was, if it's really the netting, what would happen if you utilized cantaloupe varieties with reduced netting? Would you get a reduction in risk? So Dr. Deering's team took 3 varieties with different amounts of netting: medium, smooth, heavy. And you can see the pictures underneath the electron micrographs of these. And again, there's some significant differences between varieties in terms of medium and heavy even. So what they found, the short story is that, in fact, yes, the heavy netted cantaloupe had more attachment in general. And again, this is going to vary because each pathogen is going to look a little different. They did this for E. coli, Listeria, and Salmonella. But again, each one's going to have a little bit different characteristic. But in general, you can see, the heavy and medium tended to retain more bacteria. This is a picture of bacterial attachment, and this is after they did a sanitizing step and, sanitized and then ran the test again to see what was still there. The conclusion of all this is that cantaloupe netting density does seem to have a pivotal role in decreasing the efficacy of sanitizers. The smooth rind cantaloupe varieties were more effectively sanitized. And of course, the efficacy of the sanitizers depends on bacteria type. Remember that different sanitizers affect different bacteria different ways. So here's my question for you guys. How far do you think breeders could reduce the netting on eastern cantaloupe before they cease to be identified as eastern cantaloupe? What would the buyers tolerate, I guess, is the better question. I see some nods out there like, yep, it's those buyers again causing trouble. Those expectations, boy. But again, something to think about as you look through, and I realize that a lot of folks, you kind of have a little bit of a choice with the varieties you're growing, but yeah, you really don't, because if your buyer wants Athenas or Aphrodites, you're going to grow Athenas or Aphrodites, right? Or Avatars or whatever. So again, but something to think about. Post-harvest sanitizer use in cantaloupe. This is another one that came out of Dr. Deering's lab that they've been working on. Basically trying to figure out what the best combination is, the best sanitizer combination. And this is something that we've been working with our growers. You know, I think it was our first speaker talked about how, you know, this affects an industry and could for several years and whatnot. In 2012, Indiana had a case of salmonellosis. We were implicated. The cantaloupe were implicated. One farm in our production area. That one incident cost us about 40% of our industry. So we still haven't gotten that back. And even though we have several thousand acres still, we're down to 3 growers. So again, pretty significant. And with our growers, you know, like most growers, they try their darndest. They really do. I tell people, I've never met the farmer that goes out of a morning, stretches real big, drinks that second cup of coffee, looks around and says, yep, it's a great day to make someone sick. I have never met that farmer. So, you know, our farmers like you guys are busting their humps trying to, you know, do this as best they can. We try to come along and help them as best we can. And in this study, what we found, we just basically treated the cantaloupe with different sanitizer solutions, regimes, post-harvest, inoculated, treated them with a sanitizer. They did chlorine dioxide, sodium hypochlorite, peracetic acid. These are all the different treatments, the different combinations, inline application. Most of our packing houses in Indiana, we got rid of the dump takes a long time ago. So it's going to come in and be unloaded either by gravity or by hand. And then it's going to go through a wash process because, again, those buyers want washed cantaloupe, right? And then it's going to go through some spray bars, and that's where you're going to have that sanitizing step. So again, they tried to mimic that as closely as they could with inline application. The results, again, it's a fairly busy graph with a lot of treatments. You can see there's definitely a few differences there. One interesting thing is that they also measured shelf life. How long do these cantaloupes last? And I thought that was interesting. It's like, wait a minute. I've always been told I've always been led to believe that sanitizers can increase your shelf life. So that may be true, but and we'll get back to that. But notice that refrigeration is also a big part of that. So the conclusions on this study: water is only sufficient to inactivate pathogenic bacteria attached to the rind surface. Again, remember, one of the biggest things, if you do have sanitizers, that's going to prevent some cross-contamination. Highlights the significance of post-harvest sanitation practices. Again, if you're growing cantaloupe, post-harvest is that one last chance to get it all right. We also found that the combined effect of different sanitizers can contribute to overall microbial reduction. So here's one of our most significant findings. Most of our growers would, fall in love with a sanitizer and stick with it. Either use PAA on the line or chlorine dioxide or whatever. What we were able to do was work with the growers, and based on the results, a lot of our growers were using chlorine dioxide. That's great. Chlorine dioxide requires a water rinse or a rinse step. Instead of rinsing it with water, why don't we rinse it with PAA? And that resulted in better management, further reduction of these pathogens. So again, that's something that we were really pleased because we were able to kind of do this study, and we communicate and work closely enough with the growers that within one season we had all the packing lines in the whole state pretty much switched over to a 2 sanitizer system. Okay, so something we're working on right now, fostering market access and reduction of food safety risk. This project is funded by a specialty crop block grant through the state of Indiana and USDA. Goals are to determine best practices in storage and post-harvest storage to maximize shelf life and minimize food safety risk, and determine the effect of specific harvesting practices on shelf life. So again, this is being done in cooperation with Dr. Wenjing Guang, who is our horticulture specialist in southern Indiana at Purdue. So we're through our first year of this, and basically we brought melons, cantaloupe in straight from the field. We did not inoculate them. We just brought them in, and our thinking was, let's try to understand a little bit more of this result we got with refrigeration and shelf life and how that works and how does that interplay with our sanitizer regime. So we just brought cantaloupe in from the field, ran them through a wash step, sanitized, and put those in either a cooler or out in our work area. Within about 7 days, our work area, let's just say the maintenance folks were complaining. We had some odor issues. If nothing else, we proved to ourselves you have got to have the refrigeration. But our whole point in this is to look at different varieties, especially some of the new long shelf life varieties that are coming out. And the question we're having is, with sanitizer, with refrigeration, with genetics, how far can we push this? How long can we pick a full slip cantaloupe? How long do we have to market? Ultimately, what I'm hoping is we'll get enough information, it will allow us to take our Indiana cantaloupes and expand our marketing area, and do so in a way that is not incurring extra food safety risk. So that's our goal. And again, I happened to grow up on one of those watermelon farms in southern Indiana, and we always, growing up, grew 5 or 6 acres of cantaloupe. And I had a whole experience has taught me, you make a lot more money when you can sell those cantaloupe to cantaloupe buyers as opposed to throwing them over the fence to the hogs, right? Yeah, I see some heads going like this, yeah. Okay, another one of the projects that we worked with in Dr. Deering's lab is internalization of foodborne pathogens and their prevalence in lettuce and cucumber plants. And again, you'll not see the name or word cantaloupe here, but I think this is significant. Obviously, we all know that bacteria can contaminate a crop, foodborne pathogens can contaminate a crop at any step during production, which is why we have to obviously be vigilant. You guys know that. That's why you're all here today, to learn more about this, right? So, what they did, and this is one of those places where I've got to say I'm a little bit jealous because I'm down in Vincennes. I have a BSL-2 lab, but Dr. Deering on campus, she's got a BSL-2 greenhouse. Man, that is way cool. So she can do a lot of this stuff on campus that we can't do at the regional level. So what they do, they took 2 leaf lettuce varieties, True Heart and Rio Bravo. They inoculated them with E. coli 0157H7. Leaf inoculation. Take the syringe, push it against the leaf, inoculate. After an incubation period, they tested. As you might expect, those infiltrated leaves where they inoculated and put it directly on the leaf, they could detect 100% of that. Not a big, that's just kind of common sense. You put it on there, you're going to be able to detect it. Here's the interesting part. The non-inoculated leaves, they were detecting 93 and 40% positive. What's that say? That stuff moves, or it looks to me like it may have the potential to. So they tried it with seeds, contaminated some seeds artificially in the lab, 100% positive. Do we have any folks from the seed industry in here? Okay, cool. No, I'm kidding. Again, I think this underscores probably the whole idea of using good seed from a trusted supplier. Okay, so soil. Contaminated the soil and planted the seeds, 186% positive. One thing I note, and you may be seeing this, is that consistently one variety has a higher percentage of positives than the other. So the last time I cornered our Syngenta rep in Indiana, I asked him, is this real? Do you guys, is there some genetic factor we can manipulate in the breeding to reduce risk and tendencies here? They're like, nope, already looked at that, can't do it. Ah, shoot, okay. So anyway, work with cucumber. And why cucumber? I bring this up because remember, cucumber is essentially a first cousin to cantaloupe, right? And because it's been in the news. Looking at internalization. When they do the same experiments, they're detecting the bacteria in the blossoms and the leaves and the soil and to a lesser degree the seed. Two different varieties, yet in this case, for the most part, except for the seed, they behaved in a similar fashion. That was with E. coli, the Salmonella. Same story. We can detect it in the blossoms. Conclusion, fresh produce can get contaminated from different sources during agricultural practices. Really? Thanks, Scott. Now we can go home, right? I know I ought to be careful ripping on someone's slides. They might be ripping on mine. But the key here, I think, is to understand that these things have potential to internalize and persist within the plant itself under the right circumstances. In practical terms, what does that mean? Well, think about your practices. Think about what you're doing. How can we prevent that? How can we, it just speaks to the idea of, from the time you plant those seeds or pick up those transplants from the plant house to the time you harvest, we really need to be thinking about our inputs and what that plant is being exposed to. And yes, I know, we grow plants outside. We don't grow them in a bubble. But as much as it's within your control, it speaks to the importance of your inputs and using quality inputs. For example, how do we reduce some of this risk? Well, I know none of you in this room would ever do it, but I have seen some growers out there that didn't want to go back to the shed to fill the transplanter with water and sucked it out of a ditch. I know none of you would ever do that, right? You tear the root hairs when you transplant. You transplant with the dirty water. That's a factor. That could be a problem. So again, thinking about how this stuff gets in, thinking about where it goes or what could happen, it's just super critical. Okay, so here's where we get to the somewhat aggravating part of my presentation, because Laura contacted me several months ago and said, can you come down and speak? I'd love to. Second week of December, we had 6 inches of snow on the ground. I love being in a place where there's palm trees in January. I'll come and speak and whatever. Can you talk about that longitudinal study you guys are doing? Not very easily. So my frustration is that the one that everyone is interested in, I can only give you scant information and 0 results. Here's the backstory. Over the last few years, FDA has been very active in our area and, has expressed some concerns with the cantaloupe that we're producing. So we were approached by the research branch of FDA, ALOAS is what they call it now, to do a longitudinal study. This longitudinal study is basically looking at pathogen movement within the environment. The thinking is if we know where the pathogens are and we know how we move, we can put interventions down to intercept them. So that's kind of the logic behind this. So here are some pictures. Does anyone recognize that contraption there on the left? Yeah. So didn't we see that in the last presentation?
Is that cheesecloth in the snow?
That is cheesecloth in the snow. Welcome to Northern Pathogen Sampling. So we are sampling, doing air samples across the 4-county region in our melon-producing area of the state monthly. We put these out at those places where there is an intersection of animal agriculture and cantaloupe or watermelon production or produce. So this particular one is within, about a mile of a turkey barn. We've got some that are within a quarter mile of a turkey barn, downwind from the prevailing wind. So again, you have no idea how much you guys' presentation gave me a lift, by the way. Yeah, because it makes me think I'm not crazy when we see similar things. So, monthly, which in Indiana means during the winter. This was 2025 January sampling. We only got stuck in one snowdrift and had to be pulled out. So, yeah, it was a snow day. I took my little 7-year-old girl with me. She had a blast playing in the snow while they hooked the chain up, So, so anyway, water sampling. We're utilizing dead end or ultrafiltration. So we're basically putting 100 liters of water through a dialysis filter, and then we're sending those off. The nice part about this study is that FDA is doing the lab work for us. So we send it to their lab. They do all the testing. So it really is a good partnership. And to be honest, we're not working with regulators. We're working with researchers. And we've just all really, it has worked out really well. Our growers have, it took a little while, but our growers are on board for the most part. We have an agreement with them that, number one, we don't sample product. Number two, we don't sample on farm. And number three, any results that we do get, they get those results first, which is why I'd love to share those with you today, but it's going to have to wait until after we release those in Indiana. So be more than happy to come back to the warm weather in a couple of years. But really, this is, again, a multi-year study in collaboration with FDA. Again, passive air sampling monthly, drag swabs on fields monthly as best we can. Some months they're covered with snow, some months they're covered with vegetation. We do the best we can. And then surface water sampling of a lot of the different watersheds within this 4-county area where we see the produce being grown. Other things that we're doing, I'm one of those practical guys. It's great to figure out the why and why something's happening. I'm really more interested in figuring out what we can do about it if this is an actual issue. So that's what we're doing with some of our other side projects as part of this overall longitudinal study. Growth model development, and that's our picture right up here on the left. We put out 4 different varieties of cantaloupe. And over the course of the last 2 seasons, we have measured growth, specifically number of main vine nodes. What I observe is that farmers take care of their crops. I know that's a revelation, right? But what that means is that in our case, they're using adequate fertilizer. The fertility is there. We're irrigating the cantaloupe. The water is there. So realistically, the only two limiting factors for growth and development of the crop are sunlight and temperature. So we've been able to take this node data and build models based on growing degree days and cumulative solar radiation so that we can look at the weather patterns and get really good. We're getting pretty good at predicting when we're going to see the first male flowers on those plants, when we're going to see the first female flowers, when that first ripe cantaloupe's going to appear. Why is that important? Because the lower right here, we're also looking at trying to determine if there's any one particular growth stage that is more susceptible or is higher risk. So what we did was we put out these plots, 2 different varieties. And again, this is one of those places where I really take exception with regulators. Turns out you can't grow salmonella in a lab and then go spraying it in the environment on your plots. They won't let you do that. And probably shouldn't for that matter. But what we did do is we located these plots next to a river that we knew had a history of finding salmonella in it. It floods this ground every year, so we knew the ground was a high-risk piece of property. And once every couple of weeks, we got a drone, filled it with water from that river, and sprayed it over the crops. So we're applying what we are pretty sure is contaminated water and growing in contaminated soil. And then we're pulling leaf samples, female flowers, we're marking female flowers and harvesting the fruit from those so we can say on this day when this fruit was pollinated, we know for sure there was a contamination event. So my idea, what we're trying to do, hopefully down the road, is marry this with some AI. There's been forecasting systems for plant diseases for years. Why not for human diseases that hit you right on produce? So that's what we're kind of angling towards, is starting to figure out what we can do about it, how we can work the problem here. So with that, that's what we're up to in Indiana. And do we have time for questions?
Maybe one quick question.
One quick question. That's it. I've run at the mouth. I knew I was going to go over.
It's your moderator's fault there. So.
Oh, no. Okay, quick question. I've got a quick question. Very quickly. Oh, yeah. Turning the tables. I love it. So, in my communication with Western Growers Association, they were curious, how many growers in the Southeast do you think, we mentioned the new guidelines, would be interested in attending a workshop in April to go over and learn about these new guidelines? They're thinking Dallas or Denver, some travel involved. I think I can answer the question, but since I gave my word that I would ask. Yeah. Y'all are going to be in the field in April, right? Okay. With that, then, I'll shut up.
Thank you. Okay, so our next speaker is Dr. Kristen Woods. She's a food systems resource specialist at Tuskegee University, where she serves on a team of professionals who are dedicated to community well-being, sustainable agriculture, and experiential education across the Alabama Black Belt Food Corridor and beyond. I will let you go ahead.
All right, I'm gonna have to lower the microphone, of course. Thank you, Dr. Dunn. Very happy to be here with you guys. My name is Kristen Woods. I'm a food systems specialist at Tuskegee University. And I'm going to talk about that intersection between food safety and some conservation and land stewardship practices, and specifically birds. Wild birds, not so much the broilers and the laying birds. Some additional things that you need to know about me before we get into this. I am an avid birder, wildlife enthusiast, and it colors my view of this topic, right? I am biased, for sure. I love the birds, and when I'm not at work, you will very likely see me with the binoculars around my neck. I brought them with me to Savannah just in case, right? You never know when you need a pair of binoculars to look at birds. The other thing you should probably know about me is that I used to work for the Produce Safety Alliance. For about 4.5 years, I was charged with training people to teach produce safety to growers. So as you can imagine, back 10 years ago when we started doing that, we were telling growers, clear out everything around your fields, get all of the wildlife out. We don't need those vegetative strips, get that habitat out of the way. That was a personal conflict for me, right? But because there wasn't research to show that it reduced food safety risk. But, we didn't have the research either way, right? And so we've been building that over the last 10 to 15 years. And I'm excited to get to present some of the more recent research in this area. I want to change the rules on you guys a little bit. I know the presenters like to present and then have questions after. I want to invite you guys to ask questions as you think of them and also challenge me. Right? I'm going to present research as not my own. I'm going to present some of Michelle's research. Ask her to chime in, of course. But yeah, if you have thoughts, let's just make this kind of a discussion at the end of the day and hopefully also maybe keep everybody awake a little bit more too. So, all right. So I mentioned that I work for Tuskegee University. So I have a couple slides on that because some people have never heard of Tuskegee University, but it is important that you know that this is the birthplace of Extension. So this is the first extension wagon. We call it Jessup wagon that went out into communities, held seeds, crop varieties, tools, just to help growers 120 years ago, right, modernize what they're doing in the field, increase production, and be more profitable and sustainable in those businesses. So we brought farming education to rural communities. This guy, T.M. Campbell, was the first extension agent with Tuskegee University in Alabama, 1906, right? So after that, there was an extension agent hired in Texas, and then it just blew up across the country to what we have today. We always like for folks to know that this is the birthplace of Extension, and it's still going strong in much the same way as it was back then. I work for a specific unit in Tuskegee Extension called the Carver Integrative Sustainability Center. And it's a physical center. We're co-housed with USDA. And our mission is to use an interdisciplinary approach to address rural and agricultural profitability, conservation, policy, and wellness. So it's a very diverse group of faculty and specialists that work on some of the most complex problems of rural society and agriculture. We use an interdisciplinary approach, and we develop extension programs that are specifically for marginalized populations. And just as we did 120 years ago, we still use primarily an experiential learning approach today. All right. So where we work is in the Alabama Black Belt, where we have a very high percentage of black farmers in that red area through the middle of the state. There has been a historic and actually current problem with land loss and persistent poverty in the region. So that means that we're working with a group of growers that are extremely low resource themselves, but the entire region is low resource. So we don't have the infrastructure there to build an industry. So we are working on that. So that's what I've been tasked with this last few years. On the positive side, we do have a very rich farming tradition, many farms with like generations of folks farming, and lots of resource availability as far as like rich soil. Our climate is great for growing. We have plenty of water, and we have a lot of open land mass that is currently in timber or row crops, but available to be converted to produce. All right. So today I'm going to talk about that intersection of produce safety and conservation. So I'd like to just kind of get your minds working about working around how this might work, so some examples of that, like protecting water quality and reducing erosion kind of go together, right? If we're using cover crops and planting vegetative buffer strips and using riparian zones, we're preventing soil erosion. We're keeping our topsoil in our fields and protecting water quality that way. So protecting it from pathogen contamination is one of those things. Those conservation practices where we're planting native pollinator strips or woody buffers around growing areas, those are also helping to reduce wind spread. I think Michelle and Faith mentioned that we probably don't need to sample in the woods, right? Because those are going to be buffers where the wind spread's going to stop, right? So today we're going to talk a little bit about other ecosystem services that birds and other wildlife provide in a growing area. And of course, one of the benefits of doing this and having this the natural animals out there providing those ecosystem services is potentially reduced need for pesticides there too. So have you guys seen this diagram before? Or one similar to it in the PSA curriculum? This is the southeastern version. Yeah, so there's a lot of things that are fixed in it. It's a southeastern version of the PSA diagram, just depicting a small farm in a diverse environment. Anybody have a favorite part of this? My favorite part, for this talk, my favorite part, I guess, is the buffer strip on the lower side there, where you have all the deer and what is that? There's lots of animals there that are really hard to see. There's a hog and some rabbits and all sorts of stuff by the river there and that buffer strip. So kind of have that in your head as we talk forward. And then also look on the right-hand side, there's a bare ground buffer strip. And so that's the kind of thing we're going to talk about over the next few minutes. You can see in that diagram they have a vegetative buffer planted downhill from the poultry house. Great idea, right? To catch that runoff. But on the other side where they have the cattle, they don't have that. And just imagine what might be occurring in those two scenarios on the right side and the left side of that farm. Okay. All right. So, I told you I'm not presenting my own research. I'm presenting research from all sorts of other folks over the last about 10 years. So this first one is just to kind of introduce the idea that was presented first by Dr. Garcia this was published in 2020, but that work was going on a little longer than that. And the title of her publication is actually, Can Birds Be Incorporated as Biological Control Agents into Integrated Pest Management Programs? That was a pretty novel idea a few years ago. When I first read that and I first saw that, I had a couple questions, and those are my questions on the side there. Does the literature really provide enough information on food safety risk to think about that? And do we know enough about ecosystem interactions to implement an IPM strategy that includes attracting birds and other wildlife to a growing system? 5 years ago, I was like, I'm not so sure, right? I don't know if we can do that yet. But I want to ask you this again in a few minutes and see what you think about the research now. I think this is a timely topic because I think HGAP just implemented a new standard where they're requiring an IPM strategy. And then, of course, Global GAP has necessitated native or pollinators plantings, and 3% of your land, I think, has to be in pollinators now. So all of this is kind of related, and it's important to kind of think about when you're implementing an IPM strategy or you're trying to meet those global GAP requirements, what is that doing to food safety risk too? So, all right. Okay, who has seen this before? probably got it from Michelle. Oh, is this, you're the LGMA person, the rep that's talking after me? Okay, yep, I'm sure you've seen this before. I think this was Yuma, Arizona, though. Is that? Yuma-ish, yeah. This is a representation of the area surrounding the 2018 E. coli 0157H7 outbreak. So this was a while ago, and I remember first seeing this okay, so the yellow pins are sampling sites where they had positive pathogen results. But only one of those pins was the pathogen that actually caused the illnesses in the outbreak. So they found lots of pathogens, or many pathogens, but only one that was actually causing the illnesses, which says to me that there's probably a lot of contamination in this system, right? So I thought, when you look at this, we've got the brown area as a feedlot, and the green area is our produce growing area. It seems nonsensical to do this, right? We're pulling irrigation water out of that canal that goes right through the feedlot. And I didn't know there'd be somebody from LGMA here when I'm talking about this. But it still seems nonsensical to me. We don't have anything that looks like this in the Southeast, but maybe we have other things that might look nonsensical, like, I don't know, maybe somebody does have a garden planted at the output side of a chicken house. That would be nonsensical. So we just want to think about environments, what's going on, and the proximity of livestock to growing areas. We talk about livestock or wild animals as potential vectors of moving pathogens from place to place. So, all right, so of course when we think about food safety risk, it's not a yes or no thing. And I know all day we've talked about we can't get to zero risk. It's a continuum. And so when we look over on the right-hand side of this chart, we've got animals that are high risk. Those are the ones that have access to or like to wallow in human waste. Like a rat in an urban environment would be a high-risk animal to have in an urban garden, right? Cats in an urban situation, too. And then we have larger mammals that can be, they can harbor human pathogens in their guts, right? And they can move them back and forth. And they're large enough also to move contamination with their hooves and to move. And they're big, so they move long distances, right? And then we've got things like insects and caterpillars that aren't moving a whole lot. And some of them actually reduce human pathogens in their systems. Some of them are not doing anything, and some of them, most of them actually, we haven't studied. So we don't know what's going on. I am not aware of one that amplifies risk, though, so that's good news. And then we've got some that we really are not quite sure about. They're not necessarily high risk, but they're not necessarily low risk. So like that big flock of birds there, I think those are probably blackbirds. But if we think back to the 2008 Campylobacteriosis outbreak in Alaska, there were nesting sandhill cranes that were visiting a pea field. And, well, nesting cranes, or cranes in general, they travel in groups of tens of thousands. So we're talking about very large quantities of cranes that were visiting these fields and contaminating them and then leaving. So when we think about large flocks of birds, I would definitely put them on the higher risk side of things. And then the owl, a raptor. I don't know where I would put the owl, and I don't think we've really sampled enough owls to know. They're larger, so they probably could be having some bioaccumulation of pathogens in them. But also, they're eating rats and snakes in the field. So, I don't know what the overall effect of that is. Yeah. All right, so before we talk more about birds, I promised I was going to tell you what birds I was showing. Does anybody bird in here? Any bird lovers in here? Oh, yay. Okay. So the first one on the first slide was a red-legged thrush. And I'm going to try to remember to tell you what the birds are from now on. Okay. All right. So also important to think about insects and other animals in the environment. And of course, dung beetles are an important processor of fecal material in fields, of general fields and pastures. So this comes from a study by Matthew Jones out west. I think it was like an Oregon, Washington type area, where they looked at dung beetles in natural systems, in growing areas. So what they found, of course, was improved processing of fecal matter in fields when dung beetles were there. That's pretty intuitive because that's their job, that's their entire existence, is to process fecal matter. Organic systems that included dung beetle populations showed greater fecal processing compared to conventional systems where they introduced beetles. That's important because a lot of times when we use biocontrol in the industry, we'll bring in the lacewing flies or the parasitic wasps or something, and they're supposed to control a certain plant pest. That wouldn't necessarily work with the dung beetles because we need to have that diversity of dung beetle species in order for them to be able to process fecal material and reduce pathogens in that fecal material. So they also specifically found that some dung beetle species are better at reducing E. coli O157H7 than other species. Of course, this was a limited study. We don't know if other species maybe are better at processing Campylobacter, or other species may be better at processing Salmonella. We don't know. So in just thinking about this as an entire system, now we'll kind of switch over to birds a little bit. And this is a scissor-tail flycatcher, probably one of my favorites. I think they're just gorgeous birds. It is an aerial insectivorous feeder. So it eats while it's flying, and it's not likely to land in a produce field. Also not likely to defecate in a produce field, or very little anyway. So they eat nearly exclusively insects unless they really can't find any. All right. All right, next I wanted to talk about the effect of surrounding land use on the prevalence of pathogenic E. coli in lettuce. This was by Daniel Karp, and this is actually the oldest study that I'm going to present today. It was published in 2015, so more than 10 years old at this point. They looked at, so the two charts there. At the top, we're looking at the effect of land use on generic E. coli in water. And the bottom, we're looking at the effect of land use on enterohemorrhagic E. coli in leafy greens. And then the orange bar is fields that are surrounded by other crops. The brown bar is produce fields that are surrounded by grazable land. The aqua bar is riparian zones, and the light green bar is produce fields that are surrounded by other natural areas. So they found no differences in generic E. coli when they recovered that from water in these different environments, but they did find a greater prevalence of enterohemorrhagic E. coli in the areas that were surrounded by grazable land. The one thing that the one thing that you want to notice in these charts is the extremely high variation in their data, especially when we're looking at the riparian zones and the other natural habitats. This is the first study, I think, of this type, the first one that I saw where they tried to look at this stuff. So it brought to light more questions than it did answers. Like, what are all the factors causing those huge variance bars, right? So I think we have more information now around that. Okay. So this next study was by David Gonthier and was published in 2019. And they looked at bird damage to strawberries. And they actually did an exclusion study where they They netted strawberry areas so that they could exclude birds from there, and then they measured damage in different scenarios. So they found that land with semi-natural land covering surrounding the growing area, they saw where you had more of that, they saw an increase in bird diversity species. Okay? And specifically, they saw a shift from plant-eating and seed-eating birds to the insectivorous birds, which is, when you think about it, those are the ones you want. The ones that are eating the insects are going to eat your insect pests in the field, right? So you want, if you make that shift, you're going to have less crop loss, as well as potentially reducing food safety risks, which we'll get to in a few minutes. So of course they found reduced bird damage to strawberries when they made that species shift to the more insect-eating birds. Okay? They did not look at pathogens or food safety at all in that study, or this one. This one is similar, but they were looking at bird damage and insect damage in sunflowers. And so this one was led by Sarah Cross, published in 2020, and the work was also done on the West Coast. So they found that bird damage was highest along the field edges, okay? And insect damage was actually greater than bird damage. Birds get blamed for a lot of damage that's actually insects, and it's easy to, unless you really look at the damage, it's hard to tell, right? But insect damage was 4 times greater in fields with bare or weedy edges. Now, if you think back to the strawberry study, that makes a lot of sense, because when you have those more natural woody areas around the growing fields, then you have more insect-eating birds and fewer of the birds that are eating the seeds. Right? So possibly there's more insect-eating birds in the fields with woody edges. That's what we think now. All right. Yes? Hmm?
Can you go back to that previous slide? What is that bird?
Oh, no. It's a seed-eating bird. I'm not sure what that one is. That one's maybe the only one that's not my actual picture. Sorry. But that's actually a good point. So if anybody's trying to figure out which birds they actually want in their fields, you don't want that bird. You can see how thick that beak is compared to this flycatcher. Oh, there. See how pointy that little beak is? That means it's an insect-eating bird. And if you look at the other one, see how thick that jaw there is there? That jaw is made for crushing seeds. So if you're growing sunflowers or any grains, you don't want those in your field. Yeah. Okay. All right. Birds and habitat. So this is another study led by Alyssa Olympi, also conducted out west. And they looked at birds and habitat again. They estimated that removing habitat around growing areas reduces bird diversity and could increase costs by up to 76% by the increased damage to crops. They started to look at fecal contamination this time, and they found more damage and fecal contamination was found near fences and places where birds can perch. So when we are looking at attracting birds to an environment, it's also good to think about where they're going to land. And I always think about tomato fields where you have so many stakes. And I think I have another picture in here that's a good one to look at that. But I know we've all seen the tomato stakes where there's just like feces all over that plant. Yeah. So we've got to think about that. Even if there's a low risk from some of our native species of birds, we need to do something to prevent them from perching on those stakes. All right. Okay, so this next study was Michelodi, and then this one was also conducted out west. They looked at attracting native birds and separating produce from livestock. This was So this was a massive sampling study. They sampled over 2,000 fecal samples from birds, so catching the wild birds and taking a fecal sample from them. And then they sampled over 1,200 produce samples too. So massive, large number of samples from 50 farms on the West Coast. So what they found was birds' feces were detected on 3.3% of plants. That's kind of a lot of plants. You probably wouldn't notice that if you were doing your typical walkthrough before harvest, but they went through and they were really looking for bird feces on every plant. Natural habitat did not increase the number of plants with bird feces. However, livestock nearby did. I don't think we know why. So that's an area where we need more research, and I'd love to see that done here because, as Michelle and Faith were talking about, research done on the West Coast doesn't necessarily translate out here. Non-native birds were 4.1 times more likely to have Campylobacter than native birds. And Campylobacter increased when livestock was near and decreased when there was natural habitat nearby. Also really interesting, and also would be really interesting to repeat here. We have different species of birds and different types of concentrated animal feeding operations. We don't know if it would be the same here. They found very little salmonella, just like we have in the Southeast in Faith and Michelle's sampling study. 0.02% of samples from produce were contaminated. They never were able to isolate salmonella from the wild birds. They found Shika toxin-producing E. coli in one sample out of all of their samples, over 3,200 samples. All right. So this study was conducted by Olivia Smith. Also, the research was done out west again. And what they did was try to look at the characteristics of the different birds and try to come up with the ones we want and the ones we don't want. So real quick, okay, the left is my friend's geese, right? Just domestic geese. The middle is a hawk in Belize. I think it was called a gray-headed hawk, but I can't remember. And then the one on the right, so you may know that one. Huh? No, it's not a robin. It's a vermilion flycatcher. Yeah. We have them here. Yeah, absolutely gorgeous bird. And also a low-risk bird. So the risky birds, what they found through their correlation study was that the birds that visit feedlots, bird feeders also, and areas with lots of humans, so birds that are visiting dumps and things like that, those are the risky birds. The birds that consume plants also, and the birds that live longer and are larger also, they're the more risky birds. So like the geese they're actually living on the ground, they eat plants, that's why they're over there on the risky side. The cranes would fall in the same category. And then the less risky birds are the ones that live and feed in the woods. They're insect eaters and aerial feeders, so they're not even getting in the produce. Right? Yeah. All right. Okay, now we're getting into some more recent research. This one was done by Dr. Spence, and so they looked at specifically at plastic mulch, and they sampled the mulch and the plastic and also the lettuce leaves, and they looked at persistence of E. coli over time. And so what they found was E. coli rapidly declined on all the substances, the soil, the plastic, and the lettuce leaves. You've got that solar radiation really helping with that. And then E. coli survival in the feces persisted on lettuce longer than on plastic mulch or soil. So I think that is probably especially true when you have lettuce leaves that protect parts of the leaf from the solar effect there. And then E. coli persistence was higher in feces from larger birds, probably also because just that volume protects the bacteria. Right. And then, so this one is yours, Michelle. Do you want to talk about it? Okay, I'm going to ask you if you have anything to add. The 30-second version of years of her work, probably, is that they looked at evaluating to see if the recommended buffer zones were sufficient. And what they found was, so they were looking at tomato fields specifically, and we've got crows. Crows are blackbirds, I don't know, they're blackbirds on the stakes in the tomato field. And they went to the 10 visits per farm, per field, and they surveyed contamination with bird droppings. They looked at fruit with visible bird droppings, fruit not visually contaminated, but within 1 foot of the contamination, and then fruit on the same plant that was a little further away, and then they used 10 feet away as their control distance. Okay? And what they found was low levels of pathogen persistence in general. So it was dying off pretty quickly over time. Their aerobic plate counts and the generic E. coli were higher on the contaminated fruit. That's very logical. And then the part that's really interesting and applicable to buffer zones is that aerobic plate counts and generic E. coli from fruit 1 foot away from contamination was not significantly different from their control samples that were 10 feet away. So what I take away from that is that our buffer zones are probably sufficient, right?
Yeah.
Yeah, good.
Don't pull up plants 5 feet away.
Yeah, that's not necessary. Okay. All right. All right, bees and other insects, we talked about that a little bit in the beginning, but yeah, generally they don't harbor human pathogens. Some of them actually reduce pathogens through their digestive system, and they don't travel long distance, so it's not like they're the rat or the starling that's visiting a feedlot and then taking that back to a produce area. So we just generally think of them as low risk, and that's good. All right, so the million-dollar question is, does the research out west translate to the southeast? We're building more research, but I would really like to see some of these studies repeated in the southeast, especially that massive bird sampling study, because our birds are very different. We have a different climate, water sources, different animal operations, and our migratory patterns are different, and where they are in proximity to our produce growing areas is just different. So we need more. And I think am I over time? Tiny bit, okay. So lots of programs available to help growers implement good land stewardship practices. If you're not logged into NRCS and FSA, they have quite a few programs to help with that. And in summary, we want to focus on increasing benefits, both those ecosystem services that can reduce crop loss, but certainly the ones that can also reduce pathogen risk. And we need more research in the southeast. I'll volunteer if somebody wants to do the massive bird sampling study. I am happy to go out there and help you catch birds. And you don't even have to pay me to do it. So, yeah, and that's it. I'm going to thank you guys for listening, and my contact information is up there. So, thank you.
I have time for one quick question. Someone's got something for Kristen. What's your favorite bird?
Oh, wood storks. These are not my favorite word. Wood storks on my farm.
Thank you. All right. So we have Greg Komar, who's the technical director for the California Leafy Greens Marketing Agreement. For 30 years, Greg has worked in technical aspects of agriculture and started working at the LGMA in 2019. As a technical director, Greg is tasked with helping to implement the LGMA food safety requirements and develops and delivers training programs to the industry.
All right, good afternoon, everyone. And I know I am in your way of the after-hour party here, so I'll try to keep it brief. I didn't quite know who the audience was going to be, and so I made this very introductory. So if you've gone through a root cause analysis or have general understanding of root cause analysis, you can enjoy beverages at this point because I don't want to bore you to death. But I do have some good examples, and I do have one thing I do want to point out is about root cause analysis in general. So a couple plugs. The first plug is that I am currently the co-chair of a working group through Healthy People 2030 initiative to increase the use of root cause analysis from our grower base. And then once root cause analysis has become more of a routine understanding in our community, mechanisms for sharing what we learn through our root cause analysis. So it's a huge initiative. It's been going on since about 2021. And we're making great progress. So if you're interested in anything about that, feel free to contact me. But in the future, we will be looking to bring internationally recognized root cause analysis and risk assessment training that's been developed through Colorado State University. We'll be looking to bring that to all of the growing community in North America. So this is not just a California or West Coast thing. It's actually a full North America directive. And the root cause analysis and risk assessment training that we're using has been piloted almost actually 9 times now, has had international use as well. So some Latin American country growers have also gone through the training. So we think the training is really terrific. And then we're also using some partners at Western Growers to help develop a database for sharing this information. So again, it's a pretty big project. We have a lot going on, but I'd be happy to talk to you about it more. But this picture here, obviously using AI, we've been asked to start diving into AI like most of you probably have. That's supposed to be me contemplating my life since I started really looking at using root cause analysis for the growing community, and this happened back in 2007. So I've been working on mechanisms for getting root cause analysis into the growing community's kind of tool base, if you will, for a very long time. And it started after a really big outbreak that I was involved with, a spinach outbreak in 2006 with Earthbound Farm. So I'm sure most of you are aware of the big E. coli outbreak associated with spinach. I was very heavily involved with that. I worked for the company at the time. I was QA and compliance manager at the time when that happened. And once that all occurred, my company at the time, Earthbound Farms Natural Selection Foods, was a parent company. We were really looking at ways to improve just food safety outcomes in general throughout our supply chain. So think of all the inputs that go into growing, think of all the production that goes into salad production, and think of everything that really encompasses food production. We were really looking at like the HACCP models of improvements to outcomes with food safety. And of course, root cause analysis was one of those kind of ideas that really came from, again, processed food production and other kind of avenues of failure review. From Earthbound Farm, I started working for a company called Davis Fresh Technologies. And at the time, they were a company that really helped West Coast and Latin American growers improve food safety programs. And so this was one of the first, think of them as food safety auditing and kind of consulting companies that was really working with mostly the berry industry and then also with leafy greens industry at the time. And one of the things that we did is we performed some of the first third-party food safety audits on some of these participants of our company, some of the customers we had. But as part of that food safety audit, as you guys know with GFSI audits that you probably do, Global Food Safety Initiative audits, there's a corrective action program. So if you have a non-conformance, you have to show evidence that those things have been fixed through a corrective action protocol. And then now with FSMA, right, there's also corrective action kind of language and expectations with FSMA and some of those things that are going on. But before all of that was going on, one of the things that we saw very kind of repetitively was farmers would have a problem, we'd go audit them or help them kind of improve something, and then we'd go back to them to see if there was something implemented, and they would be doing the same practices, the same failures would happen routinely. And so we started requiring for certain levels of nonconformance, a root cause analysis be conducted, and we would work with them to kind of help them through some of that, right? So this is kind of really kind of before Michelle and Faith and everyone else started doing some really heavy duty root cause analysis when there was an outbreak or something like that. This was like more minor in the sense of like something the farmer could actually implement themselves and do without maybe third-party assistance except ours, right? And we were kind of hopefully a cost-effective way for them to do that. But anyway, so now let's move forward. The LGMA was created, right? And then in 2010, the Arizona LGMA, so there's two LGMAs for those who don't know. There's the California Leafy Greens Marketing Agreement and there's the Arizona Leafy Greens Marketing Agreement. So we're sister organizations. And so, by the way, LGMA in Arizona now has a 1.5 mile buffer from a super CAFO, right? California style is only a 1 mile buffer. But so just so everyone is aware that it has changed with that longitudinal study that just got completed in Arizona. And for anyone who is interested, there's a very important longitudinal study that's concluding in California, Salinas Valley as well. And those initial reportings will happen in March. So if you're interested in learning more about that, that is also coming. So there's a lot to be learned from that longitudinal study as well. But anyways, long story short, the Arizona LGMA contacted me when I was at Davis Fresh Technologies and said, hey, we're seeing a lot of repeat nonconformances. Would you give a presentation about root cause analysis? And so the presentation I'm about to give you is pretty much the identical one I was giving them back in 2010, because it really doesn't change the fundamentals of what we're talking about, even though, again, I was messing with AI and started putting some new pictures and stuff in there. So just keep that in mind. So root cause analysis. So what is it? I mean, I'm sure most of you can kind of appreciate, right? You're really looking at, you have a nonconformity and the level of nonconformity is important, right? When we're talking about this, but you have some sort of nonconformity and you really want to understand why that nonconformity occurred, right? So you're looking for the determinants behind what drove that nonconformance. And then it also has the intention, right, of a CAPA process, a corrective action and preventive action process associated with that, right? So you're looking at how to improve outcomes from a long-term perspective, right? So you have a problem, you're looking to fix it, correct that problem, but then how do you prevent it from happening in the long term? Looking at what is the root reason why those problems occurred. And the root cause is not just the corrective action. So that was one of the issues we were seeing with our own growers when I was at Davis Fresh Technologies, and what Arizona was asking me to do when I did this training back in 2010 was we're seeing a lot of folks are doing the Band-Aids, but they're not really getting to why the things are happening and how do we prevent them from happening again. And so we just wanted to start really socializing the idea of what is a root cause analysis, right? So what was mentioned, some folks were talking about Western growers, so the previous cantaloupe presentation, right? So Western Growers Association is actually the owner of the LGMA California standard. So when you think of like, we have this standard, we call it the metrics, we have food safety requirements. In those food safety requirements are actually requirements to do root cause analysis under certain circumstances. Like, so a pretty important failure occurs with our metrics. In some instances, our membership is actually required to do a root cause analysis to try to determine what caused that issue. So it's not pervasive through our requirement, but there are some areas where that is a requirement. Now, when it comes to ownership, right? So again, Western Growers is the manager and owner of our metrics. The LGMA doesn't own those because it's kind of like the fox guarding the hen house, right? We want to make sure that there's a really rigorous kind of process for updating our metrics. We're obviously heavily involved, but we want someone else to own it. Now, as far as like other resources, we partner with Western Growers quite a bit, right? And so from a Western state perspective, there's a lot of things that we use from a resource perspective that Western Growers helps us either develop or we help finance them and then they develop them for us. And one of the things that we've developed are these things called appendices, right? So we have appendix documents with our metrics. So they're kind of like how-to documents, if you will. How do you do some of the things, or what's the technical justification behind some things so you understand kind of as a grower or an operator, what are we thinking you want, what do you need to do here and how do you go about doing it? Well, in that regard, we also have multiple root cause analysis resources as well. And so this stuff you see here about decision matrix comes from one of those resources that we have. So from a Western Growers perspective, we have when to do a root cause analysis and how to do a root cause analysis. There's two different kind of documents. So this comes directly from one of those documents, okay? So I just want to kind of, and that's, you see the kind of on the bottom of that character there, like the, you know, the document that this comes from. Now, this you know, root cause analysis resources, they were developed many years ago. And I would say the important takeaway from this isn't to kind of like, the next couple slides are going to go into really details and kind of have a numerical way to decide when should I do a root cause analysis, okay? The context of all this, I don't necessarily agree with. I think some of this needs to be updated, and it's kind of still a little bit elusive. So when should you as a grower potentially do a root cause analysis? And I would say my colleagues over here who have kind of done them from like a really significant, serious outbreak or recall perspective would tell us, you rarely do them, right? It's gonna cause like something really important should be happening on your farm, or something repetitively happening that could really cause a problem for you to probably wanna do one of these things, because they're, for the most part, really difficult to find. You know, we've done a lot of them as an industry, and we typically don't find a root cause analysis when we go through them. But I will say this, it's important to practice these things. It's important to understand how to do them, and it's important to try to do them, because even if you don't find, like I have this problem over here and I'm trying to find the root cause of it, when you actually go through this process, one of the take homes that we usually find is you find other areas that you can improve upon that are really valuable for your farm. Angie mentioned in one of the first discussions about the, you know, making sure that, you know, the stool, the financial stools of your farm are balanced, right? That you have, that you're profitable. Well, one thing we find from doing these root cause analysis is that you really do find some process improvement steps that you can take that are really going to help your farm in a lot of ways, like quality, cost effectiveness, a lot of things, right? So these can help you in a lot of different ways, but of course this is a food safety discussion, so we'll go and that, keep on that discussion, but they're very valuable in a lot of different ways, okay? So should I do a root cause analysis? Some of the things to consider if you're going to do one are, you know, the repetition or frequency of some issue. So you're having something happening either kind of repetitively that's kind of like could lead to a potential issue from a food safety perspective. The urgency of the issue, you know, if this thing continues to happen, what could that mean from a risk perspective, from a health outcome perspective of my customer, consumer? You know, again, the scales, right? 1 to 5, 1 being not much, 5 being very serious, right? So think of it as scales. And then number or volume, like how much of your product or output is going to be potentially impacted if I do not figure out what's going on, right? So these things to kind of think about numerically, right? Again, just an idea. This is not set in stone. These are for things for you just to think about how you might start tackling the idea of when should I do a root cause analysis, okay? So again, the repetition and frequency, you know, in this area, I'm just gonna lean on a water system issue, right? Because that's something we do see, unfortunately, right? And probably can have some ability for you to kind of gleam onto a little bit. So this one guy, you know, one farmer, hey, we keep having water failures, and there's the personal lab coat is the extension agent researcher coming out to help them try to understand what's going on. Number volume, right? Many acres might be impacted, right? So again, how much are we talking about here? So if we keep having these water system failures, what does it mean, right? And then urgency, and this farmer, you know, she's the head farmer. She's like, I'm worried about water contamination, right? So she gets it, right? She's using some sort of a water source that they're trying to treat, and the treatment's failing, repetitively failing, and they're like, whoa, you know, we need to have, this is like our critical control. We need to understand how to make sure we can fix this, right? So if you start going down the scale, right, from, again, low numbers, meaning, you know, you don't need to do a root cause analysis, but maybe a corrective action, all the way down to a really important high number saying, yes, immediately do a root cause analysis. And then what are the mechanisms for root cause analysis? There's kind of things that we should think about. So in this water system failure example, what happened, water test shows high levels of indicator bacteria over and over and over again, even though we're treating this water system. So we shouldn't see this, right? We should not be seeing these high levels of indicator bacteria. Has it happened before? Yes, it's happened many times. 4, what is the urgency significance? I'm irrigating with water that is a high risk and touching the edible part of the crop. Moderate risk. 3, because again, just because it has high indicators, as we saw with the previous presentation, doesn't mean there's pathogens in there. It doesn't mean you're actually contaminating anything. It's just an indicator of something potentially at risk there. And then, of course, how much product is impacted, multiple acres. So it could be a lot, significantly financial impact to the farm. So I'm just highlighting the number 9 to 11, implement corrective actions immediately. So like Band-Aid it, fix this, make sure you are treating your water, but then try to understand why this keeps happening over and over and over again. All right. Pretty self-explanatory, I think, right? So again, this is just a model, right, of how to potentially think about it. There are other ways I'm sure we can discuss, but just kind of keep that in mind, right? We're just trying to help you put a way to kind of measure when I should do it. Because once you go down that path, it can be very time-consuming, very financially costly, because a lot of root cause analysis in our world goes around like sampling and testing and kind of other things that you may have to do, a lot of verification activities, and so it can become costly and time-consuming. And then there's report writing and other things, right? So you kind of want to just kind of be measured of when you might actually do something like this. So defining is really the key, right? What is really going on? And I think with all the trainings you might go to in the future, including the one that Colorado State's developed, there's a lot of emphasis put on really defining the problem, because if you define the incorrect problem, you start going in directions with root cause that will waste your time, resources, energy, and whatnot. So it's really important to be very clear, what is the problem that you're trying to solve? Then you start to investigate it. We'll talk about investigation in a little bit, like what does that mean? Ultimately identifying from your investigation, okay, I found maybe what the issue is, and then of course the corrective action, preventive action process, and then the verifying and monitoring. So that's really the steps, right? Really the steps in a nutshell about how does this work. All right, so as I mentioned, we go into great detail in other trainings about defining the problem, but this is just one slide. Is you're gonna have this problem, you're gonna start getting people together, and you're gonna be like, let's get on a whiteboard, let's really start to figure out like what is the problem. And you start kind of looking at it, and at the end of the day, the idea is like the people you bring in, you're gonna have this root cause team, right? So so if you're a farmer, you probably don't have a big team necessarily, but you're gonna bring in people that may know something about this issue. In this case, we're talking about water in this example, right? So if you have irrigation staff, if you have a third-party contractor helping with anything, and then of course, if you may have an extension resource or some other resource, you'd bring them in and start saying, okay, we're starting to see these issues, what could it potentially mean? What are we looking at, right? The communication of happening, that's really about a bigger organization, right? So if you're a smaller organization, the communications be very clear. You're going to talk to the people that are kind of involved with your organization. When you get into bigger organizations, like for instance, a couple years ago, there was a really big outbreak and recall associated with the Dole company that spanned multiple states, multiple products, and it kind of boiled down to a moving piece of harvest equipment, but it took them a long time to figure it out, and it took a lot of resources and downtime. So when it talks about communication, right, they had this really complex thing going on. So again, it's all in layers, right? So, but the idea is always with everything that we're trying to kind of like keep it simple, keep it succinct, right? It's just like, what's going on? What do we think we need to do here? And then of course, as much as you can, again, you're growers, right? And so food safety is from your growing staff. Your location is your farm, right, for the most part, but it could be going to a supplier, right? So you could be like, hey, we may be having an issue with an input. We may have to go visit them, right? So it really depends on kind of what the issue is in general, but just don't do this via Zoom or anything in modern times, right? You're gonna want boots on the ground, kind of start really figuring out what's going on with some of these issues. Now with like, you know, you think about an airplane crash, right? There's kind of the unfortunate airplane with the UPS plane that crashed recently, right? It's like, we're not talking about that here, right? Those are really kind of crazy, high-resourced root cause analysis, but the general premise is the same. What you're trying to do is go back and kind of reinvent what potentially is going on, right? So you want to go back. So in this case, I'm having high indicators in my irrigation water, but I shouldn't be. I'm treating my water for this purpose. Ultimately, you're going to want to probably start the treatment process, right? Because you're like, well, it shouldn't be happening, so is there something wrong with my treatment process? So it's either the source water, is something changed significantly, the source water that's really impeding your treatment, or your treatment process is broad. I mean, you can see where it goes, right? But then you start wanting to go and go back to the process, right? So, you know, what are you supposed to be doing? So how's a treatment process supposed to work, right? The procedures, work instructions. what are the records that you may have, like chlorine levels or whatever that case you may do, like what are some of the records showing us? Observations, so go watch the person who's supposed to turn the system on and how are they doing it, you know? And of course, I say photographs if permitted, right? So again, if you're working with a third-party vendor of some kind, they may be like, no, you can't take pictures of my proprietary process, but you can maybe do this or that, right? So those are kind of the ideas about the photos. But again, in your case, you're just there kind of observing what's going on and trying to understand a practice. So I keep, you'll see this throughout the presentation. It's not based on hearsay or unsubstantiated opinions. You're really trying to get to the facts of things, right? So it's not, I think they're supposed to do this. It's like, they're doing this. It's very different, right? And then record the objective evidence. So as you start going through it, it's just like you're an investigator. You're like, hey, I saw, my irrigator doing this, right? So you keep those fresh in your mind because these could take a few days, right, or longer. So you want to keep your kind of your mental notes on paper or documented somehow. So again, you're collecting evidence, right? And then one of the cool things, like I was mentioning earlier, right, when you start conducting a root cause analysis, you are going to like throw things on the board. You're like, well, maybe this is what's going on, right? And you're going to look at those things and you're like, okay, that's not what's going on, but you're still not supposed to be doing it that way, right? So we looked at this thing and when I was looking at how you're delivering the chlorine 375-gallon chlorine tote, and you're not buckling into your forklift like you should be, right? Because if that forklift flips over, you're a dead person, so put your seatbelt on. So you start seeing things like that you can just automatically start improving of your overall program. So those are really cool kind of things about digging into these investigations. You start seeing improvements elsewhere. But from a food safety perspective, it's the same thing. You might say, oh, my training, I did this training and I thought it was clear, but clearly my training didn't work out the way I expected it to. So I need to change these little parts and make it more clear, right? So you start changing these things. And we'll talk about that in a bit. So of course, as you're going down the root cause analysis process, there's the open and closed questions. Same thing as auditing. So it's a very auditor kind of centric idea, right? But closed questions versus open questions. You don't want to allow people just to give the yes, no answer. You want them to describe, it allows for a descriptive kind of on a conversation perspective, right? So again, an open question, not just a yes, no answer, right? So as you start talking to your irrigators, you start talking to the people kind of responsible for the area that you're looking at, in this case, water, don't just give them a question that's a yes, no answer. Have them describe to you what's going on, and I think you'll obviously get the idea of why that's better than closed questions. And then this slide just goes again into examples of what are open and closed questions. I won't kind of waste too much time on that, but just get the idea, right, that closed questions are not good. But we as, unfortunately, like what we've seen, because in agriculture, we're not processed food that has a shelf life of a bajillion days, right? It's like the product needs to be harvested, or the product has been harvested and it needs to go somewhere. You got a few days. It's like we really want to rush to the conclusions because that's just our nature, right? We're really go, go, go. We need to get an answer to move on to the next thing. We got a planting coming, we got a harvest coming, blah, blah, blah. Or this product needs to be irrigated. It's drying up. I need to find out what's going on in this dang irrigation system. It's like we're going to naturally gravitate to those closed questions because we're trying to like get to somewhere, and it's really important not to do that. Okay. Now, of course, with root cause analysis, and a lot of you probably have seen this, right? With a show of hands, the 5 whys of root cause analysis. Have you heard that before? Yeah, a lot of you have, right? So this is just, again, the way to help you get to the root cause. You keep asking questions until ultimately there's not another question you can ask, and you're like, okay, this is the base, this is the foundation problem that we're seeing. So if you see these examples here, again, this is not about a chlorine or a indicator issue, but it just goes to show my system's failing, my plants are drying up. Why? Okay, my filter's clogged, okay, or we're not maintaining our filters, our sand filters, so it's not working, right? And so you can keep going down, and it's a very simple way of doing it. Now, at the end of the day, we hope that when you all are doing a root cause analysis, it's this simple. Unfortunately, it's usually not that simple. Even though we always strive to keep it simple and keep to the basics and all that stuff. But ultimately what we usually do is this guy here, a fishbone diagram, which is you kind of look at kind of antecedents or kind of factors that may have more influence or less on a potential outcome. Typically those are people, the methods of doing something, equipment, materials, the environment that you're working in. These are kind of the a lot of the factors that we kind of deal with. And then at the end of the day, this was what I was talking to you about earlier, right? You're going to find holes in your program that you're like, I need to fix that, but that is not the urgent one right now, or that's not the pressing one. I'll get to that at some point, or maybe I just won't have the resources to even do that one, but it's on my to-do list at some point, but it's not going to cause me to have an outbreak necessarily, but this one over here is really, really critical, and I need to take care of this, and you can start aligning resources to what's important over time, right? And that's what's really valuable about these things. But again, it can really, really overarching, nice process improvement kind of program developing for you that you can just kind of tackle when you have the time and resources to do so. But again, at the end of the day, you as the operator will have to determine what is the most urgent, critical thing. And this is where talking to some of your cohorts or getting some expertise to come out and help you understand, it's like, I only have $1. Where do I spend that dollar, right? And we get that, right? That's a total practical way of going about it. So a couple, yeah, again, just the audit trail, right? So as you start kind of going down this path of the fishbone or the why, kind of idea of a root cause analysis, you're gonna start seeing things, and where does it take you, right? Where is it taking you? It's called the audit trail, right? Or the kind of the idea of like, what do I need to focus on, right? And again, it kind of can help you to develop a means to develop your hit list for a later time as well, right? So when you've done that investigation, right, you're all said and done, you're like, okay, this is my hypothesis, or this is what I think is going on. Now you tackle it, right? This is the evidence is pointing me here. Now I'm going to go and tackle that and try to fix that, right? Corrective action process, preventive action process, and then ultimately I want to review that in time to see if I have actually fixed this, my indicator should be going down now, right? So that's kind of the idea, is you race to fix it, okay? Now, when you're all said and done, right, let's just say, for instance, this is a very serious issue, right, that potentially implicated product or something like that. You have no evidence to say I need to do a recall at this point or whatever, but I was like irrigating with water that was like risky, right? I still need to use the water, still need to harvest my crop. That's what I do, right? But potentially there's an issue here. What you're going to want to do is document all this, right, so that you can show diligence, right, that you have something that if ever, when you get your PSR inspection once every 3 years or however frequency it is you get them, and the inspector starts looking at some of your documentation, they're like, hey, have you had any issues? And you're like, yeah, I have. They're like, what'd you do about it? This is what I did about it, right? It's really strong evidence that you're doing your diligence and that you're really proactive about your food safety management on your farm. So it's a really good thing to do. It's just a summary. It doesn't have to be crazy, right? You don't have to have this extensive report, and there are extensive resources for you to do these things as well. Not just the training from Colorado State is very intense training, but the Community Alliance for Family Farmers has great resources on this. IFPA has, all the extension agents. They all have these kind of cool resources that help you with some of these things, right? To kind of help you. And of course, now with AI, you could just probably like, help me write my RACA report, and it goes, spits it out for you, and then you can maybe change it a little bit. All right, so when you're writing, just this again, common sense type of stuff, right? Smart language, specific, meaningful, appropriate, relevant, timely. So this is the same thing if you're giving your employee a review, if you're like trying to get your kid to do something you want them to do and they're not. It's like give them something, you want to, the same thing with these reports, you don't want to be writing anything that's going to be unclear, and that it won't allow for effective implementation moving forward. Okay. I give some examples of not smart language, and some examples of the kind of the smart version of that. Right. You can kind of put your own, the people that you deal with on a normal basis. Right. Some people you just like they get under your skin. Right. They say certain things to you, and you're like, gosh, if you just say that in a smarter way, I can maybe work with you. But that doesn't always work. But just kind of again, keep the language, direct. What do we need to do? What are we trying to accomplish here? And then of course, at the end of the day, as I mentioned, the root cause analysis is not the corrective action. The root cause analysis is trying to determine what the cause is. Once you determine the cause, now you have the CAR process, corrective action process, right? And then the preventive action, the CAP, we call it CAPA. That's its own animal, right? So root cause is one thing, and then your own corrective action process is another animal, and those take different resources. But at the end of the day, the expectation, especially from a federal perspective, is that if you know you have a significant issue, you need to correct it. Now, the time that you get to correct things and whatnot is different depending on what the issue is, but you're going to need to show resolution, right, from a documentation perspective. Just some examples of corrective action. Again, I was talking about the chlorine tank, right? So if the examples of poor smart language versus good smart language, the tank was damaged or had some issues, right? So replacing the tank, so that's a very common thing we see in the ag industry. Listeria positive on that, pallet jack, just throw the pallet jack away, get another one, right? That's a corrective action, right? That's not like, how did the pallet jack get Listeria in the first place, and how am I going to prevent future pallet jacks from getting Listeria on them, right? Those are very different things, as you can tell, right? Retraining, that's a very common corrective action. We see that in our LGMA corrective actions. That's like the number one thing we see. I retrained their employee on the spot. The inspector was there and they saw me retrain them. There we go, okay. Corrective, good job. Remove the error, again, just really Band-Aids, right? Preventive actions, right? You're doing things that are going to help you prevent problems in the future, right? So the inherent in the name, right? So you see the little picture putting the little red siren showing that the chlorine level's down or the pump is broken or there's an air bubble or whatever the reason why the chlorine treatment system wasn't functioning in the first place, right? They're going to do something that's a little bit more proactive to help them manage that process. And then ultimately, right, after a certain amount of time, this has now gone bye-bye, you're on to your next thing, right? We do this a lot, right? It's like, okay, we tested that, that's now stored in the archives. Every once in a while, you're going to want to go back and be like, did we really fix this, right? Let's see what's going on. This is very important. We see this a lot in facility management, of course, right? This is a huge part of our deal. And we also recommend, right, if something is so urgent that it caused you to do a root cause analysis in the first place, that obviously somehow gets into your routine operational kind of programs, right? You're like, oh my God, we went through this big process to get this fixed. Let's make sure we're keeping an eye on it moving forward. So how do we redirect resources and make sure this is front and center moving forward for us, right? Instead of just something we're reviewing annually or whatever, right? Because we have best intentions, right? But there was one of the presentations earlier, I can't remember, but as people, right, we're gonna kind of gravitate back to what we know or what we're comfortable with, right? So even if we know this is the problem and this is what we're supposed to do to fix it, but I've been doing things this way for 20 years, I'll do it this way, but eventually we start seeing creep, right? We start seeing people go back to the things that they're comfortable with or easy to do, and change is sometimes hard, right? So we want to make sure to review these things every once in a while. All right, so that's it. These are the resources I was telling you about. You can go to our website, the California LGMA or Arizona LGMA. We have all these things. We have resource library. Some of the folks in this room have used those actually for recent issues in the Southeast even. So if you have any more questions about root cause or want to see some of the other resources, just contact me. But all of our stuff is free, so you can just go to our website and get it. And with that, hopefully that wasn't too boring.
When gathering data, one of the things you brought up is that when you're going through the process is to review your records. Something that I have discovered is there's a lot of falsification of records.
Right.
And so this might reiterate the importance of correctly recording your observations, because if you end up having to do a root cause analysis, you're starting off with flawed data.
Right.
And you may never be able to solve your problem because your records are faulty.
Right, yeah, that's a great point. Yeah, no, that's one of the things we're challenged with too, obviously, in our auditing program to LGMAs. We actually have a requirement to review impactful records, like a supervisor review, but again, that doesn't mean even if it's reviewed, it's gonna be accurate or anything like that too, right, or not falsified. So we're challenged with that. It used to be a broader challenge. It seems, you mentioned earlier about food safety culture too in your conversation. I would definitely say that's one of the things we see in the LGMA community, right? It's not perfect, right? We have excellent contributors. We have a lot of folks in the middle, and we have some folks that still don't really they just become LGMA members because they have to sell to Canada or something, you know what I mean? But at the end of the day, you know, we do see culture as a big part of what we do, and we're implementing some things, data sharing, for instance, and whatnot, that really wouldn't have happened 10 years ago if it wasn't for some of the culture that we're developing. So it's important. It's for sure important. How do you measure it and all that? I think it's just in actions, right? You can see some of the actions occurring, at least on that side. And I will say, you know, again, the presentation earlier about buffer distances and whatnot, right? So one of the things I was talking about earlier is I'm part of this Healthy People thing, and just one more plug for that program, is until we can learn to share as a community, it doesn't have to be with us, you know, but sharing even from a Georgia perspective or a Southeast or whatever, we have been doing our share. So we have a romaine test and learn pathogen testing sharing program in the California LGMA. It's not in Arizona yet, it's only in California. We've been doing it for over 2 years now, and we are definitely learning from this program. It's amazing. And I was telling some of my colleagues just the other day, I thought I'd be retired before anything like this would ever happen. So it's possible. You can do it in a confident, classified, you know, way. You know, you don't have to be worried about getting like the big FDA folks after you, or you know, any of that data getting out. But it's like been really helpful for us as an industry, and I just see it getting better. So, sorry. I know you guys want to go, so turn on the music.
Any other questions? All right, well, thank you.
All right. Have a good evening.